Hey folks, welcome to my stream. Today we will be going through the code with Claude. We are starting with the inside Canva AI, architecting an agentic system for millions of users, how Canva pushed out their 2.0, and then we will be going through the rest of the videos in this series. And after that, we will be going through Apple's DubDub or Microsoft Build, depending on what we feel might be next.
Canva Danny Wu ステージへようこそ Canva AI プロダクト責任者 Danny Wu 様
Konnichiwa and hello everyone. Thank you all so much for joining this session at Worklog. I'm Danny and I'm head of AI products at Canva, and I'm really excited to be hopefully sharing some of our top learnings from building Canva AI 2.0 with Claude with all of you, and hopefully this will be helpful for all of you builders out here. So let's get started with the agenda. I'll briefly cover a quick overview of what Canva AI 2.0 is and share a few of our top lessons, including how we actually redefined what our success criteria was as we learned. Things we've learned around building our agentic harnesses, how we manage cost at scale to serve tens of millions of users, and a little bit around responding to and really listening to community feedback. So I want to first start with a bit of an intro about what Canva AI is. And if you don't know what Canva is, it's a graphic design and visual communication platform that lets you create everything from docs, presentations, posters, emails, and pretty much anything you can imagine you can create it with Canva. And Canva AI is really designed to help our user base and help our community achieve all their design and productivity workflows. So here's a little video. If you have something like you can connect all your data sources like Slack, Google Drive, Calendar, and more, and really use Canva AI to get your work done inside Canva, like getting all the right context from, and then using it to create a doc, create a design that you can edit natively and really, really easily and collaborate to get work done. So I also want to talk a little bit about Claude. At Canva, we have been using Claude since the Sonnet 3 model days, and as we've all seen with Fable earlier today, the frontier intelligence for Claude models continuing to advance. We're seeing it increasingly solve some of our hardest challenges that was more or less unimaginable just a few months ago or several months ago. And of course, we run fairly comprehensive evals across all sorts of different tasks, workloads on the trifecta of quality, cost, and latency, and Claude consistently delivers. One thing that's especially good and that we love about Claude models is their visual superpowers, and this goes beyond front-end design. We find that it generalizes really well to everything from creating polished presentations, including on brand decks, but also all kinds of visual artifacts from just anything from printables to docs and so much more. And another thing that's especially great is the flexible deployment options. And for us, having Claude available on Bedrock, Vertex, and Microsoft Foundry is more than just a different API endpoint, but it's a way for us to build and use Claude inside all of our AWS accounts, inside of with our IAM roles, permissions, and cost tracking. So it makes it really, really easy to integrate. And now I'll give a bit of an overview about Canva AI 2.0, which is actually a fairly complex agentic system. So while it looks like just a simple text box on the surface, it is actually something that orchestrates quite a combination of different agents, like our design agent or code agent that powers Canva code, as we saw earlier today. But it also has really hundreds of different tools for all kinds of tasks, from things like image generation to background removal, magic layers. And essentially what we are continuing to do is really baking in all the different features, all the different things that normal user could do to the Canva platform, but really integrating them and having them as tools that Canva AI and our agents can call. And of course, we've got the platform layer where you have all of the connectors, all the MCPs, memory, scheduling, and everything else. It might look a little bit simple on the surface, but getting this to work and create a cohesive experience for our users is a little bit more complicated, especially with increasing powers of AI models and user tasks. And now I want to say a few challenges. So at Canva, we do have a distributed AI team. We want our whole organization to be working on AI. For example, we want our video group to be working and have ownership of video AI. We want our print group to have ownership of all of our print features and everything. And so we really need to find patterns that scale across an organization of about 5,500 people. And Canva handles such a broad range of jobs to be done. And in terms of scale, especially with the launch of Canva AI 2.0, everything has just continued to grow. So scaling is definitely a fun challenge. I'll start with the first lesson, and that's really around defining the problem and really building solutions that connect with users. And for us, it's actually learning that empowering our users to design isn't necessarily just about one-shot outputs or how good it is. And this is because, and while this is obviously a dream, we love to be able to translate a really broad prompt into an amazing output from the get-go. There's a lot of considerations. For example, design is inherently subjective. Different users have different tastes, have different preferences. We've got different teams and companies. They've got certain brand systems and brand kits that need to be integrated. And there's not necessarily a right design that's perfect for a task. There's rubrics, there's evals, and there's user preferences. But design is inherently subjective. And from what we find, both through internal testing and really talking to our users and early testers of Canva AI, the human touch actually does really matter. For example, the average Canva design is edited about 110 times before it's been published. And what we've sought to build with Canva AI 2.0 is not just an agent that is executing things in the background and able to complete the designs and just a little down toggle, but it's really something that can work with you, something that you can steer, something that you can really work alongside as a super design collaborator. And finally, latency and responsiveness is one of the top goals. We actually find really, really strong correlations. Since Canva is interactive and our users expect to be able to complete the design needs quickly and effortlessly, we see a huge correlation between user satisfaction, feature retention, everything with the latency. And sometimes there's actually even more than our quality metrics and rubrics. So figuring out how we can make the agentic system not just really good, but also really fast matters a lot. And I'll show you an example of how we've actually applied this to the design agent. If you look at the start, we've got what's the Canva template, and that's obviously not personalized, not customized, but a really, really great starting point. And the middle of the pack is what we found is our sweet spot, at least for now, in terms of the amount of effort and the amount of the design quality we want to get before handing back initial design to the user. If we spend a lot, if we get the LLMs and get the models to work for a lot longer and spend a lot more tokens and spend a lot more effort, also correspondingly more time, then we can get a little bit of a more polished output, as you can see from the slides. But that's not necessarily what most of our users prefer. And of course, if you do ask something really amazing, we'll make it for you. So this is really about how at least the way we see it, there's a little bit of an efficient frontier or a sweet spot for models. And it's not necessarily about quality maxing. It's not necessarily about, I guess, I'm going to the lowest cost, but finding the right effort levels, finding the right prompts in our agentic harness to really get to what is like the right spot where most of our users are the happiest. Now, the second lesson, and this is around our agentic harness and how we're increasingly seeing that this as disposable. I think with the rise of just how powerful agentic engineering is and new models like Fable, but also really with Opus Power models, this is just a quote from me. But I think today's clever harness is really tomorrow's dead code. Harnesses and what boundaries you set, it's constantly changing with new models. You find new things that work best. We've seen this a lot with our own journey. So we've had some form of Canva AI for the past 3 years, and we've essentially rewritten the entire Canva AI harness at least 3 times. As we adapted to new models, we originally started with doing internal chain of thought prompting before moving on to taking advantage of native model capabilities. We started leveraging more and more tools. The early versions of Canva AI maybe only had 3 or 4 tools. Now we have hundreds of tools. And my whole point here is really harnesses. Writing harness is something that you should continue to iterate and something you should continue to evolve. It's not something. It might be okay to keep on building things and keep on testing things, but especially when there's a big jump in models like the Claude 5 family, it's the perfect starting point to really reevaluate what you actually need and whether giving models more power can give you better outputs for lower quality. Better outputs for lower latency and higher quality. What's really important here and what is not disposable, but what is really, really valuable are evals. And for us specifically, we started moving to this recently, end-to-end evals. The way I would think of this is if you're a software engineer, you might write unit tests, and those could be traditional evals that measure the performance of, say, a specific task or a specific feature. But when you're building a complex agentic system that has things like user memory, that has things like external connectors, that has things like integrations, then you really want to make sure that your end-to-end flow is working and behaving the way we expect as you do A/B tests, as you test different system prompt changes, or even test different models, different effort levels, and so much more. These end-to-end evals are what really gives us confidence in launching new features or rolling out things to 100%, as well as really understanding what's the best way to leverage the model's capabilities. And it's a list that will continue to grow and expand, and really it's kind of our mode for building better and better Canva AI. Getting there isn't super simple, and it is definitely an iterative process. It's something that you can start. We've started our initial ones maybe had 10 or a dozen test cases before we've added hundreds and hundreds more, and then we've started having to only run a portion of these evals just to make the times work. And what we found super helpful is really having surfaces and having mechanisms to be able to launch features and launch experiments to users, to early adopters, beyond your internal team really early. Once you launch to some users, every time we find that users either have different expectations to what we thought, usually not that far off, but usually a little bit different, and the feedback and how users actually use your agentic product, not what you have in your, say, marketing videos or press releases. That's what you need. That's what you need to have your evals to really deliver a great experience. And also give a bit of a call out for signals of success. I think it's really important to actually be very deliberate when you're doing experiments to measure the right metrics. We found things like do users spend more turns on Canva AI to actually not be that helpful, because when you have say a more powerful AI agent, users find it to complete the task in less turns, actually get a design faster and spend less time on your platform and get their work done. And that's a good thing. So my advice is don't necessarily go for engagement metrics or things like time spent or turn spent, but rather does it help you users get the jobs done? Do they come back to your system? What's your retention? And really the combination of all these will help you build agents that really perform. Now getting to a meatier and hopefully exciting topic, and that's managing cost at scale. Canva AI is used by tens of millions of users and growing each and every single month, and it's continuing to accelerate. So and the vast majority of Canva users are free, and we believe it's really, really important to be able to offer AI to everyone, to students, to people who might not be able to afford, say, upgrades to Canva AI right now. So that's why we try to make it as efficient as possible. And there's probably 3 key takeaways that we found really helpful. The first one is setting term budget limits, and the task budget feature in the public platform is actually surprisingly effective and has certainly surprised us in terms of how much models scale. Smart model routing is another really important area. Usually all the hype is around the most powerful and the latest models, but honestly across the whole core model family, there's some really, really excellent performers, and one of the biggest ways you can optimize your cost is to ensure that you are always using the right models for the right workloads and tasks. And finally, I'll talk a little bit about creating a positive culture across the organization, especially if you're in a large company where there's many developers and many builders contributing and building to your AI. So the first one is around term and budget limits, and I guess why have this in the first place? If you're used to code coding, you're probably thinking, gee, it's a bit annoying if your product actually interrupts users and stops them before the task is actually completed. But especially for our product, which is used by users of all AI skill and proficiency levels, we often see prompts that are not entirely super effective. For example, if you look at this prompt, keep working on each and every page in this deck, which could be a 40-page deck or maybe even sometimes a 100-page deck until it's really, really good. Frontier models will do an amazing job at it with unlimited time and with unlimited budget. But if you don't have unlimited usage or budget to offer to users or in a session or when costs matter, then setting constraints and actually the instructing the model and giving a bit of a budget to complete a term really does help. And finally, no matter what, no matter how much you test, no matter how much you optimize, you spend any time, especially when you're dealing with external systems or external connectors, you're probably going to see what we call doom loops every once in a while, when an agent might keep on trying the same thing again and again and again, and that's not really great if it blows past the user's entire budget. So our goal with term budgets is really to help our users get the most value out of the AI limits that they do have and ultimately have a happier experience. the first thing that I encourage all of you to start with and explore if you haven't is term budgets that was introduced on the topic platform fairly recently and for the latest models. So with term budgets, you can basically instruct Claude, hey, you have like a 32,000 token budget, you have a 50K token budget, and you leave the decisions up to the model to actually budget itself and manage how it executes the task. So here's some examples with one of our design generation harnesses. We're using the same model and giving the same prompts. Nothing else changes in these examples except the term budget. And you can see how Opus actually scales incredibly well and delivers a presentation of a form across essentially like half an order of magnitude of term budgets. Determining what the token budget is, like that's definitely something that's very harness specific, but Frontier models, Opus, and even Fable, they do scale incredibly well across both effort levels and term budgets, and those are things that you can control to help deliver more optimized AI experiences. Seriously, they're so powerful. And one thing I will note is that task budgets only count tokens, and if you have an agentic system, you probably do have tool calling costs. So for example, image generation costs a little bit of money, like things like web search might cost money. So what we have done and found to be actually really effective is to essentially like follow similar patterns to how task budgets are implemented, but also for us, track and have costs for all the different tools. We did this in a very similar way, and essentially like at the start of the task, we instruct the model like Opus with what the budget is for the session. And once in a while, during a turn, we give it a reminder of, hey, you're this way through, and finally, once it has reached a term budget, we ask the model to wrap up and finish its work. I will note that generally like these things like do work fairly consistently, but not 100% of the time. They are advisory and they're hard limits, so you should also have hard systems level enforcement if hard budgets are important to you. And ultimately, like where you get to what the sweet spot is for your application and for your use cases is something that you need to profile yourselves based on the workloads you want to support and what your cost profile is. This is actually we still have the specific numbers here, but it's actually real from Camera 2.0. We did an analysis of our user sessions and really tried to set a good limit that allows for a very sensible and very decent amount of work, but also use the latest and most powerful frontier models super effectively. And there are a lot of things you can do to actually make term budgets much more user-friendly. And you can do this just through system prompting and giving instructions. For us, the pattern that we found that works really well, especially in an interactive agent application, is offering helpful next steps, like communicating what the agent has actually performed. If there's any actions that the user has asked for that it has not performed, like in this case, where it added 10 slides but haven't finished things due to the term budget, and asks users for either additional context or steers, but also offers to simply continue the task. And the second part, beyond term budgets and limits, is really smart model routing with sub-agents. And why sub-agents? I'll take you through an example with Camera Code. So our minimum viable product and version 1 of Camera Code was just using Sonnet, which is very simple and very straightforward. But for simple queries like editing some text or replacing a graphic, you really don't need Sonnet. Haiku is going to do an excellent job. And so we experimented and tried model routing, where when giving user prompt, we would either send it, depending on how complex it is, we would either send it to Opus or Sonnet or Haiku. And this initially seemed to work, but it actually has some downsides. And primarily, every time we switch models, we have to write the cache again. And since we're editing code, like the context windowing might be tainted, so the cache is no longer coherent. And in a lot of cases, the cache writes that we're paying for might actually override the benefit. So we moved on to a more, so we moved to a sub-agents approach, and this is ultimately what worked best for us with Camera Code. We have a main agent that has essentially the canonical context and plays a little bit of an orchestration role. And depending on the task, it can choose to delegate that to an Opus sub-agent to perform it, or Haiku sub-agent to perform it, and then send it back to the main Sonnet agent thread. This worked really, really well because it kept caching rates really high in the high 80s and 90s instead of constant tracking and writes. We ultimately almost half our cost and delivered user satisfaction to boot. And finally, the last thing around cost is really having great reporting and monitoring systems. This is not just useful for you, but it's also really useful to having great dashboards where you have tracing for all your costs, every session, and everything that's involved in an agentic session is a great way for you to get Claude to also help you profile and help you find, test, and experiment with optimizations. We also find that surfacing costs in our internal staff UX to have really helped, and this has been especially helpful for discovering edge cases where what should be simple or very cheap requests consume a significant amount of tokens or costs due to edge cases or bugs. I definitely encourage you to not be shy about surfacing how much every single agentic action or every single interaction costs to your internal team and maybe even to your users as well, depending on what your customer is. It's just so important to know this and have this available with every single action. The last one that I'll cover briefly is around user feedback, and I'll share a story of one of our recent launches, Image Upscaler. So we launched our internal in-house image upscaling model just a couple months ago. After some great A/B tests and evals, we rolled it out, and we got a little bit of mixed feedback. So here's some feedback from our community users around the image upscaler. And this was despite the fact that we saw we had such huge confidence that usage of our upscaling was up by a few multiples. Our eval cases generally looked good, but we also had a minority amount of user feedback, but really local feedback. So what we listened to. What we found helpful is really leveraging the feedback and support channels and really having the systems for capturing and surfacing any user feedback directly to you and using it to categorize and transition them to the relevant teams and tag them into the relevant features. So we got hundreds of examples from our community around where the image upscaling model wasn't performing as well. We added this to our evaluation. We learned a lot of things. We learned that for some specific imports and specific upsells, it didn't work super perfectly. There's some other edge cases. And what we ultimately did is pretty much added all the examples our community has submitted to our evals. We trained and rolled out version 2 and then got to 100%. And finally, a closer loop with our users. And if any kind of users that still has feedback on upscaler, image upscaler right now, please do send and share it to us because we always love to make it better. But really, it's so valuable and so powerful to be channeling your most vocal user feedback and even complaints into learnings. And just because the minority of users, just a few percent, even if your evals look good, even if your metrics look good, that doesn't necessarily mean you've always hit the spot. So very briefly, so you can grab lunch. Some key lessons is really about empowering the human and making sure that you are striving for what actually helps your users the most. Harnesses are getting more and more disposable. Don't get attached. Don't fall in love with them. Evals are what really matters. Cost control, like task budgets, if you haven't tried it, highly recommend you try it out. It's incredibly powerful. Effort levels, models, choose using the right models, the right tasks and sub-agents. And finally, listen to your community and all your feedback. Thank you, and arigatou gozaimasu.
So this was good. They presented a harness for every step, and they will be updating it with the new Fable 5 and Mythos 5 models that came on. And Canva kind of does it every time since it's totally dependent on the slides, and the content structure is totally dependent on what gaps it finds, and those gaps are to be improved by the prompt engineering and agent engineering part of the harness. So you got to uh, understand the nuances of the model and write a new harness every time something comes out, some new model comes out, so that you can achieve the task that you were set to do, the goals that you had previously. That's kind of cool. Moving on.
Please welcome to the stage members of technical staff at Anthropic, Jess Yen and Michael Cohen. ステージへようこそ、Anthropic テクニカルスタッフ、ジェス・イエン様、マイコー・コーエン様。
Welcome to Code with Claude, everyone. I'm Jess, product for Claude Managed Agents.
And I'm Michael, engineering for Claude Managed Agents.
It has been so exciting to see the organic uptake on Claude Managed Agents and how we're accelerating meaningfully developer workflows. This is a story that we want to share with you today. We've seen uptake from disruptive startups all the way to the largest enterprises, and we want to make sure that you can all benefit from the kind of experiences that they've had as well. So first, we'll go over the exponential that we've seen in AI capabilities and what that implies for building agents. We'll talk through the patterns we saw in agentic development and why that motivated us to build Claude Managed Agents. We'll go through the building blocks for building an agent, including some of our more recently announced features, and we'll round things out with a fireside chat with one of our hero Japanese users, Rakuten. So as we've all seen, models are getting exponentially more capable, and so are our expectations. The more advanced our model capabilities, the more sophisticated the work that we're delegating. We're now seeing that the bottleneck is increasingly the infrastructure and not actually the intelligence. So let's bring this to life. 2 years ago, when Opus 3 was announced, you might have it write and test a single component. It would take minutes of focused work. Last year, when our Claude 4 models came out, we leveled up, and you could debug an entire set of files. You might be working for an hour or so, but you'd be steering heavily along the way. With our latest models this year, you're now seeing them run overnight, across agent teams, listening to your linear backlog and actioning the whole thing before you wake up. And now we suspect that in the near-term future, with models as capable as Fable, we'll enter a world where agents are capable enough to accomplish tasks that would have previously taken entire teams of people quarters to achieve. And agents will run this entirely autonomously. So you might see that multi-agent systems could coordinate and run an entire M&A pipeline end-to-end in a fraction of the time it would take us. And so as tasks have graduated from low-level instructions towards end-to-end outcome description, we now need far more than just prompts and tool loop. We need reliable and scalable agentic infrastructure.
That's exactly right. And the more complex these tasks, the deeper the access we'll need to give these agents in order for them to be effective. With models like Fable, we really need these they're able to do very complex tasks. You can't run an effective agent without granting it access to your credentials, your internal knowledge bases, or your databases. If you want these agents to produce code for you, you need to give them access to your actual code bases so that they can push up PRs and go to production. And finally, you need to grant them identity and authentication. Our agents are increasingly acting not just as Claude, but as me or Jess, with our emails and our Slack. And as we grant agents these human-like capabilities, we expect to interact with them in much more human-like ways. The shape of interactions are changing, not just the duration of these interactions. Some agents are very conversational. You steer, provide guidance along the way. You might even interrupt it if you think that it's going off path. Some agents on new models like Fable are really, really outcome-oriented. And if you have a strong signal or a rubric of what you want to see get done, you can provide it that rubric and let it iterate until your exit criteria are met. And then finally, you might start a task a couple of days ago and then want to pick it up much later. A robust agent platform needs to support all these sorts of interaction patterns. And the infrastructure and primitives that we provide have to give you all this out of the box while still being very, very flexible so that you can customize them to your needs.
So it's now becoming clear that we expect a lot of our agents. And historically, this has meant that we've pushed the burden onto you, the developer. In research we conducted prior to launching Claude Managed Agents, we saw that developers were genuinely eager to climb the exponential with us, but we're struggling with a few key areas. So first, context management. The right context at the right time is actually really difficult to tune, even though it's completely necessary. And providing context at the wrong time can be a huge distraction for your agents. Half of our developers are citing that infrastructure concerns are their #1 production blocker. So agents create bursty workloads, they have unpredictable compute patterns. It's super difficult to scale securely while also hitting latency targets. And lastly, observability is genuinely incredibly difficult. How do you know when your agent is producing quality outputs? These are non-deterministic models and they're producing huge amounts of unstructured data. And so enter Claude Managed Agents. We did the platform work so that you don't have to. Managed Agents combines infrastructure, agentic primitives, and out-of-the-box observability, all available in a package on the Claude platform. We'll dive into each of these components in more detail throughout the course of this presentation, along with a couple of demos.
So let's talk about the very basic building blocks of Claude Managed Agents. At the very, very core, you have an agent that you define. This would be the system prompt, the model you want to use, any skills that you might want to have loaded into your agent, and tools with permissions for those tools that you want that agent to have. This is like the agent's identity. Next, you have the environment that you configure. This is like a template where you define a network allow list and any pre-installed packages that you might want to have. This is like the world that the agent is going to live in. You take that, the environment and the agent, and you use that to run a session. A sandbox is provisioned for you. We set up the harness, and Claude starts executing. Any credentials and resources that you might want to include in that session are mounted into it and are available for Claude to use. Finally, we have events. These are anything that the agent produces as it's doing actions, or any events that you might want to provide upstream in order to steer the agent. This is how you might want to stay in the loop. Events and stateful awareness is really where we're able to provide a platform so that you can build your own products on top of. And you can use primitives like memory and other features that we have in order to really optimize the performance of these agents.
So as Michael mentioned, events are the heart and the crux of what an agentic integration entails. So let's demystify what that means in practice. Everything in managed agents is event-based. So these are durable transcripts that are clearly structured to help you track your agent's progress. So first, there are user events. These are actually what you're sending to the agent to guide it. Next, there are agent events. This is what the agent is actually doing. So this is messaging, this is tool execution, context compaction, and even delegation to other agents. Next, there are session events. This is how you understand the progress of the unit of work that you've just delegated. So this is overall lifecycle, the status transitions, errors, and outcome process. And lastly, there are span events. There's a lot going on in this event stream. This helps you group related events and just see things in a more aggregated, instrumented way.
So let's pivot to a real world example of something that we built using Claude managed agents, which is Pascal.
A lot going on in this.
So this is interesting. The event topology looks like user events, agent events, session events, and span events. And the different messages, interrupts, compaction, tool use and results, confirmations, outcome definitions, multi-agent coordination, the outcome processes, and the outcome evaluations. They all span across multiple different topologies.
Event stream. This helps you group related events and just see things in a more aggregated, instrumented way.
So let's pivot to a real world example of something that we built using Claude managed agents, which is Pascal, which uses a hypothetical online grocery delivery services order data in order to analyze that data and provide insights for our team. The agent produces analytics in minutes, leveraging a preloaded data set and a set of Python packages and scripts that we installed and uploaded into the container that it works from. You can see every event in Claude console and even chat with a debug agent in order to further optimize your integration. So going into the video itself, this is the Pascal kind of homepage. You can pick off an agent session and Claude will get started. It'll take a couple minutes to complete. So while it does that, we'll go over to the developer console and we'll actually see the events that Claude is producing in real time and be able to better understand what Claude is doing live. We can also actually look at the agent configuration and environment configuration that were set up for this session. So this instance, that's the system prompt and that's the model. And moving over to the environment configuration, you can see the network permissions that were allowed and the packages. Jumping back to the actual page itself, it seems like our analysis is more or less done and we can actually dive into the insights that Claude found. On the product side, it seems like bananas are really, really popular, as well as a bunch of other products that are really popular, but everybody should get their bananas. Looking into customer insights, we see that Sunday afternoons are really, really popular for online orders. So you might want to schedule your orders for a different time of the day. And then finally, we set up this prediction simulator that lets us analyze whether or not a customer is more likely to reorder things. Jumping back to the developer console, we can see here in the side panel that we can pick off an analysis of the session itself, where Claude will look at all the events and further come up with insights for us on how to optimize the integration that we built. In this particular instance, we see that some of the scripts that we gave Claude are actually really, really slow. So we may want to optimize the Python code that we wrote for them in order for them to do better. So we just looked at the developer console, and you saw that in action. But there are really many different ways for you to get started with Claude managed agents today in order to interact with these agents that you create. You just pick whichever one fits your workflow best. My favorite one is the Claude API skill that we have available in Claude Code today. All you have to do is ask Claude, hey, I want to get started with using Claude managed agents, and it'll help you with the onboarding flow into your existing code bases. Next, we also have the NCLI, which we released recently. It makes it really, really easy to interact with our APIs for scripting and CI/CD pipelines that you might have. And then lastly, we have our developer docs and our cookbooks. These provide a lot of practical examples and copy-paste ready examples of the most common patterns that we have for Claude managed agents.
So now that we've covered the basics, I want to touch on some of the more advanced features that we've recently shipped. So first, multi-agent orchestration. Here, Claude is able to delegate tasks to other agents with independent context windows, enabling it to parallelize increasingly complex work. With outcomes, Claude iterates on predefined exit criteria or a rubric until it satisfies its goal. You're in charge of this goal, and Claude is in charge of completing it. With memory, Claude is able to read and write to memory stores. By default, without memory, Claude would be starting fresh on every session. But with memory, it has an awareness of prior runs and can do better this next time. Dreaming is built on top of memory. And here, Claude is reflecting and codifying on the learnings and codifying it into new memories. And this ensures that it can continuously start with a tighter set of more curated and optimized memories. All of these are really exciting intelligence features, and we're really excited to raise the ceiling of what agents can produce. However, we also have heard that we need to meet you where you are, and that means making our infrastructure more modular. So with self-hosted sandboxes, you can run the agent loop and have tool execution directly in your infrastructure, so files and packages never leave your perimeter. With MCP tunneling, Claude can access private MCP servers that you would not want to expose to the open internet.
Yeah, this is cool too. The multi-agent orchestration and the self-hosted sandboxes we talked about previously too. The outcomes, predefined exit criteria, dreaming that reflects and codifies learnings into new memories. Memory, of course, we discussed it that about this, the memory stores that it has. So currently, I was doing this explicitly, having loops and hooks, and to manage the memory and write everything to the memory and then read it every time. So if this can do it step by step instead of like a snapshot of everything that happens, that will be good too. So we need some kind of a granular control here in the memory space, as other agents are doing, specifically with the factory.ai that has those memories defined, in which after every step or after every achievable goal, you tell it to write it in the empty files, and then when you have a new session, or you clear the context, or you kind of load it from there. And the MCP tunnels also kind of helps here inside your private networks without exposing them to public internet. So all in all, cool.
Each of these things are built so that you can deploy within your enterprise within your own security principles.
And in addition to all these amazing features that we already have, like Caitlin mentioned earlier today, we just released 2 new very exciting features. One is scheduled deployments, which allow you to set up a recurring schedule on which will trigger new sessions on your behalf for any recurring work that you might have. And then next we have environment variables inside vaults, which allow you to provide secure credentials for any APIs or CLIs that you might want Claude to call without actually having any sort of risk about Claude seeing the actual secret tokens. Diving a little bit deeper into how
Yeah, so this scheduled deployments is good too. Recurrent work without having to triggering or run, and environment variables in the vaults that need API keys while keeping them hidden from model.
having any sort of risk about Claude seeing the actual secret tokens. Diving a little bit deeper into how environment variables work in vaults, we place an opaque placeholder token inside the container itself that Claude has access to. And whenever Claude is trying to hit an API or use a CLI, it will just use that environment variable the way that it would use any other environment variable. And as that network request is made, we will inject the real secret value as the request is made, so that Claude may never actually see the value of the secret token.
Thank you so much, Michael. It's been so much fun building this platform with you. I'm now excited to welcome to stage Yusuke Kaji-san, General Manager at Rakuten for AI for Business, so that we can talk through what he's been building. Welcome, Yusuke-san. So Rakuten calls its AI strategy AIization, and agents are the next big phase of that. So what does that look like day to day?
Yeah, first of all, thanks for having us in the stage, and welcome to Japan. And so for Rakuten, we have the AIization activities, which is basically our effort to fill the gap between the capability curve you mentioned and adoption in EIT. So what we do is that we completely redesign our workflow from scratch as you release new models every month or every quarter, so that we can basically fully unlock the potential of the intelligence or from the new models by fully redesigning our workflows. Yeah.
Got it. And so what did it take for you to get agents into production at Rakuten, knowing that you've been on this journey for a while? And what would you skip if you were starting today from scratch?
Yeah. So when we started developing agent ourselves, we spent tons of our time and effort to manage the infrastructure of the agent. But if we were starting today, we would skip that process and fully put our focus on agent experience and building some loop and close the loop of the agent instead of spending time for the infrastructure.
Got it. So I'm excited to hear that managed agents is helping accelerate that work now. So what has made the biggest difference in the quality of your agent's outputs over time?
So I'd say the self-evolving capability would be the biggest differentiation factors. Oh, sorry, I forget. Okay, so basically, in one day, we deploy the agent, and initially we have some mistake, and our agent makes a mistake. But by enabling the memory and the dreaming you just described, we are able to let the agent improving their capability by checking their trace pass run, and then address the problem or the mistake they made last time. So thanks to that, we can actually address 90% of the problem we initially had in our real process. And thanks to that, our agent became more token efficient, and also the latency and cost is decreased significantly.
I'm really glad to hear how much value you're getting out of these features. We just announced also the scheduled deployments feature this morning. So what recurring work at Rakuten did you put on the schedule first?
Yeah, so first we put a lot of reporting and analytics tasks into the scheduled deployment. So in our company, we have a lot of the process of the task which require the repetitive the work. So for example, we have a lot of sales reporting or the marketing reporting which require the presentation deck or the spreadsheet and do some data analysis. So thanks to scheduled deployment, we are able to automate those repetitive tasks and delegate those tasks to our agent. And also, our users also use it to take the log and metrics from our public cloud so that our product manager can see the health status of the application without creating any new dashboard.
Very exciting. And I guess similarly, we also released environment variables supported in vaults, so agents can use authenticated tools without ever seeing the keys. So what is this unlocking for you?
So the use case I mentioned now is actually unlocked by this vault because in order to make sure that we can use agent safely and align with our governance and compliance, we want to make sure that those API key and the credential will not be exposed to the agent itself. So thanks to this vault, we can actually onboard this monitoring agent so that we can see the status of our application in real time.
Very, very exciting. You guys have always been on the frontier of what we've been building, and we can't wait to keep pushing this platform forward with you.
Yeah.
Thank you.
Thank you.
So today, you've gotten to hear about Claude Managed Agents as a platform and how it's accelerating some of our most frontier users' work and workflows. You also got to hear from Yusuke-san at Rakuten on how his team's productivity has accelerated meaningfully because of Claude Managed Agents. If this has resonated with you today, and I hope it has, then please feel free to walk by our demo booths where we will be all day to show you some demos and help answer questions about Claude Managed Agents. And then additionally, these QR codes that you see on the screen right now point you to some of our more tactical resources, such as our documentation and a rich experience in console that lets you build an agent from scratch in minutes. So really, really wanted to extend such a thank you to all of you for staying with us today and hearing about what we've built. Can't wait to see what you will build going forward. Arigatou gozaimasu.
Please welcome to the stage, General Manager of AI at Rakuten, Yusuke Kaji. ステージへようこそ。楽天 AI ゼネラルマネージャー、梶祐介様。
こんにちは。楽天グループのジェネラルマネージャーの梶と申します。本日は楽天でAI ナイゼーションと書いてありますけれども、アンソロピックがいろんなモデル、いろんなエージェントというのを日々リリースしていく中で、どういうふうにそういった技術からビジネス価値を作っていくかというところを楽天のケースとしてお話をさせていただきたいというふうに思っております。はい、本日は私のお話をさせていただくときに、主にこの2つの軸というのをベースにして、この後ずっとお話ししていきたいなというふうに思っています。この図がどういうことかということなんですが、まず1つ目は自律化、上の縦の方の軸ですね、オートノミーというふうに書いてありますが、今日の朝のセッションでもあったように、どれだけモデルなりエージェントが自律的にオートノマスに長い時間動けるかというものを示したものです。で、右の横の仕事が解決できないというところになるかなと思っています。ちなみにちょっとこの私の今の今回のプレゼンテーションの日本語訳が若干少し
Hi, I'm skipping this since this is in Japanese and I won't be able to understand this. Next talk.
県最高 AI 責任者、藤井達人様。そして、みずほラボリード、染谷健太郎様。
はい、入ってます。はい、皆さんこんにちは。みずほフィナンシャルグループの藤井と申します。よろしくお願いします。今日はですね、みずほが AI を前提とした組織とそれから開発の仕組みをどういうふうに作っていくかというのを、30分という時間になりますけれども、ご紹介させていただきたいというふうに思います。単なる AI の活用し、現場だけ任せていくとになります。
This is in Japanese too. So skipping this talk.
Hi everyone. 皆さん、はじめました。私の名前は Theo です。今日はよろしくお願いします。Hi everyone. My name is Theo. I'm a research product manager at Anthropic. I work on our long horizon capabilities, such as long context and memory capabilities in our models. I joined about 2 years ago, right when Sonnet 3.5 had recently launched. At the time, agents were barely a word that people were using. There were just signs of life that the models could even do coding at all. People were still focused on chat completions. Autonomy and agent autonomy was something that was still kind of a new concept. Around this time last year, when I go back to Code with Claude last year, Opus 4 had just launched. Claude Code was not even GA. It was still a pretty nascent thing. We didn't know if it would quite take off. It was still pretty new that models could be used for autonomous coding. And of course now we have Fable, we have Mythos, and recently had also launched Opus 4.8. So before I go into the talk about the capability curve and how models have improved over time, I want to ask you all to raise your hand if you've heard of Claude. Okay. Now raise your hand again if you've used Claude. And keep that hand raised if you think Claude makes you twice as efficient. Okay. Keep that hand raised one more time if you think Claude makes you 10x as efficient. Okay, pretty good. This time last year, lots of people did not even know what Claude was. When I was at Code with Claude last year, people were still asking me, tell me a little bit more about large language models. What do they do? How can I best make use of them? And so it's really insane to walk around this conference and see how much more awareness there is around AI, how many more people are using it in their day-to-day life, and how many more people are not just using it in their day-to-day life, but seeing the gains in their own productivity and efficiency. More code is written by Claude every year. We recently released a blog post about recursive self-improvement. Over 80% of code internally at Anthropic is merged by Claude. And so as you can see, as models improve over time, we very much expect that capabilities and ceiling of those capabilities are only going to get better from here. And so this talk is about how you adapt to this new world and how you as developers can actually think about building for the future instead of just building for the past. So you can see on this slide that we have a series of models and how they performed on Smooth Bench Verified. This is a trusted coding eval that we use internally to look at Claude's coding improvements. This eval is made up of a series of GitHub issues, and Claude needs to pass these issues and in a sense run on tests to see whether or not it has successfully passed that issue. And if you look all the way back to Sonnet 3.7, you can see that it scored just a little over 60%. With Opus 4.8, it is now scoring 88%. And with Mythos and Fable models, we have seen that this benchmark is actually saturated. This is a pretty insane improvement. I don't think the line fully captures how insane of an improvement this is. From 62% to 88% in just 12 months means that Sonnet 3.7 actually failed 3 times as often on these tests. Just think about that for a second. And that is the rate at which models have improved just over the last year, and models are only improving faster and faster. And so what I'm about to show you is the same task done 12 months apart by 2 different models. So first we'll see Sonnet 4 performing on this task, and then we'll go and look at Opus 4.8 on the exact same task. The task that I'm about to show you is rebuilding Claude.ai, our Claude website, in one shot. And so Sonnet 4, as you can see, is writing quite a lot of lines of code. It's calling a lot of tools. It's jumping right into it. It's acting before it's planning. And when you actually go and run the UI, you can see here that it actually doesn't work. Looks reasonable, but not completely functional. Now, the Wi-Fi might be down. Well, voice over what Opus 4.8 would have done on this instead. Opus 4.8 would have built the exact same UI, but it would have actually had the same colors that we would have had on Claude.ai website. You would have seen the sidebar, you would have seen the chat interface, you could actually send messages and they would actually respond correctly, and it would plan before acting. And not only would it plan before acting, but that planning before acting would ultimately lead to far fewer tool uses called, far fewer lines of code written. And so at the end of the day, what you're seeing is that Opus 4.8 not only does the task more successfully, but faster and cheaper. So before I get into the tactics of how you can actually build in this new world, I want to talk about where the intelligence gains are actually landing. So the first thing that we'll talk about, again, as I mentioned, is this idea of planning before acting. So old models would, be like me with IKEA furniture. They would jump right in, not look at the instruction manual, just kind of start building, and then kind of fail at doing the thing, and realize that they had to go back in and actually look at that instruction manual. So they would just kind of jump right in and act before they started planning. Now, models actually plan first, and what that means is that they're thinking through what the spec should be before they actually go and execute on it. And by doing so, as you saw, or would have seen if the Wi-Fi had worked, with Opus 4.8, is that the models are actually more efficient by pre-planning that spec. And as it's pre-planning that spec, it's then able to actually catch mistakes. So you might see things like the model saying words like actually or never mind, but by catching those mistakes, it can actually execute on the plan more efficiently the first time around. And so what this means for you is that you should allow the model to think first before actually doing the task. Build your products in a way where that thinking is allowed in the user experience, where you're actually giving the model higher effort and adaptive thinking so that it can then do that planning upfront. The second area where we see a lot of intelligence gains is in error recovery and self-correction. What I mean by this is that old models used to do this thing called doom looping. Doom looping is the idea that the model will be given a task, it would go and do that task, it might fail on the task, you would tell it, hey, I think you should have done this other thing, or maybe something in the environment gave it feedback that it should have done this other thing. It would say, great, let me try it again. And as it tried again, it would just kind of keep running into the exact same solution that it had previously and would not change its approach. Now, models are able to actually look at that feedback and react to it, and they will actually try something different and try again, and oftentimes this leads to a better outcome. And so what this means for you is that you should think about designing your environments in a way where you can actually give that feedback to the model so that it can actually then recover from any errors that's hitting along the way. This also means that instead of doom looping and just wasting tokens, models are actually able to perform the task with fewer tokens overall. And finally, models now are improving at running over longer and longer horizons. What this means is that models are actually able to sustain attention and hold coherence up to often 1 million tokens, sometimes even more. Old models would lose the thread partway through. They might forget the task. You might have heard people say that sometimes they see models, quote unquote, losing the plot. This is often what people say when a model kind of forgets the task along the way, maybe it forgets the instructions along the way, and so it kind of starts going a little bit off what you expected it to go on. But now we're seeing that this has improved significantly more. And of course, there's still room to improve here as you get better at longer context lengths. But now you can actually allow the model to run up to a full 1 million tokens. What that means for you is that you don't have to do as much context management. You don't need to chunk up the context window as much as you used to. Though, of course, if you do want to run for much longer than 1 million tokens, you may still need to do some of this. So I'd recommend, as you think about models going for longer and longer horizons, that you actually just dream more ambitiously and give it much longer tasks where you can hand it an entire code base and not just a single file. And what this means is that models now can plan a lot better. They run into fewer failures as a result. But when they do run into those failures, they're able to recover more quickly. And finally, they can just run for longer and longer horizons. And so all of this compounds into these agents that are able to run a lot more autonomously. And they can then do longer and longer tasks over time. And so they're able to then do more and more intelligent tasks over time. So what this might look like is something like the chart you see here, where agents first plan. After they plan, they then execute on that plan. You might give them some way to verify against that executed plan. So maybe, again, this is human feedback in a conversation, or this is some tool that the agent can call to verify their outputs. They then use that verification to then adjust the plan, and they kind of go back and loop on this again until finally they are happy with the final result. But don't just take this from me, take this from our users as well. Here we have a quote from Shopify, who has seen that Claude Opus 4.8 is noticeably better at error recovery, at planning before acting. Cursor has seen that tool calling and token efficiency in our models is much improved, and that Opus 4.8 is better than every other Opus model that they've tested. And similarly, Cognition has also seen that Opus 4.8 is much more autonomous, can run for much longer horizons, and similarly is also more token efficient. So again, as models get more and more intelligent, you can kind of just let them go for longer periods of time, and they're able to work on tasks more efficiently and effectively than they were previously. So this is the part where everyone's probably most interested in, which is tactically how you actually now build for this feature. How do you build for the models that are getting better and better over time? This is not just about Opus 4.8 or Opus 4.7 or any of the models that we have today. This is really about helping you guys understand, as models improve, what should you be thinking about as a developer so that you can actually give your users those intelligence gains that we're seeing in the models. And the first thing, before we even get into the tactics, is a mindset shift. Be ambitious with what you try and what you allow Claude to handle. Don't keep testing the same tasks that you think Claude could have done 12 months ago. Start to think about tasks that Claude can't do today, and think about how you continue thinking about tasks that Claude can't do today, because as models improve, more and more of those tasks are going to be possible, and you want to be able to see as those tasks become possible. And the first way that you do this is by building evals. Refreshing your evals if you already have evals, but oftentimes this is the first step for people to even understand what is possible in models today. So if you don't have evals, the way to think about this is that they are unit tests for the AI era. Some of these can be regression test-based, where these are all tests that the models today can already do, and you're just looking to see whether or not your harness or future models are able to do the same things. But often, what you actually want to do is create evals that today's models do not saturate. And so what this means is looking not just at the current customer experience that you're providing to users, but the customer experience that you want to provide to your users over time and the direction that you want to take your application. And building for those test cases and putting those test cases in your evals. This also means looking for failure modes that your users are reporting to you, adding those to your evals, and seeing if new models actually then solve those failure modes. Secondly, update your evals that might be saturated. So we sometimes hear from customers when we launch new models that they'll say something like, hey, on my eval, it only really improved by 1%. I don't think this model is that much better. And over time, as they start to play around with the model more and more, they realize, oh, actually, this model is significantly better on a couple of capabilities, or maybe this one axis that the eval just didn't test for at all. And so this is a testament that if you're seeing that your eval is not moving very much, you may want to look at whether or not the remaining problems that are not yet solved by models in that eval are actually fair and solvable. And if they're not, then your eval might be saturated. And if it's saturated, then it's time to update that eval and look for harder problems. And finally, once you do have that eval, the best thing that you can do is just benchmark it so that you understand how various models are performing on it, and as new models come out, to actually then look at how those new models are performing on it. Secondly, and I can't say this enough, shrink your scaffolding. Scaffolding is the prompts around the model, tools that you might be using around the models, any code that you have. Sometimes people also call this the harness. But as you look at your harness and your scaffold, oftentimes people are adding new things to it over time because of various failure modes that maybe prior models ran into. And so an example here is that we at one point had a line in our Claude AI system prompt that specified a specific citation format that was now out of date, was not a citation format that we were using anymore. And our new models got significantly better at instruction following and started following that instruction in the system prompt that we had put in there a while ago. And so we thought that citations were broken in this new model until we looked at the system prompt and realized that actually the model had just gotten better at instruction following. And what we really needed to do was to just remove that line entirely from the system prompt. And this is an example where shrinking the scaffolding and just letting the model have a little bit more autonomy actually helps you to see what that model can do in practice. And so what you want to do is write your prompts for intent and what you want the model to ultimately do, and not just to write those prompts around all the past failures that you may have run into with prior models. And finally, you want to give the model room to work. So we talked a little bit about this when talking about giving the model room to think. You want to use adaptive thinking, which gives the model the ability to decide when it needs to think and how much it needs to think. And there's also an effort dial that you can use to actually dial up or down how hard the model works on problems. Secondly, you want to allow your agents to have more access to your environment to take more actions, but do so in a controlled way. So as we talked about, models are becoming more and more autonomous, they're becoming more intelligent, but to actually take advantage of that, you need to give your model the actions and the capability to take those actions. And one way that we do this internally is that, as we talked about in a recent blog post, we launched auto mode in Cloud Code, which is a classifier that tells Claude what actions are safe to take. Of course, you don't want to just allow your model to kind of run wild and maybe delete everything in its environment. And so you do want to be a little bit controlled with what it has access to. But doing it in this kind of classifier way allows us to kind of strike the right balance of how much control we want to take, but also how much control we want to give the model. And finally, you want to close the agent loop. And what I mean by this is that, as we talked about before, models are now very good at error recovery, but it needs to know when it has made an error. And so the way that you tell the model whether or not it's made an error is by giving it a way to verify the outputs. So for example, maybe if you're building an application building agent, you might want to give it a computer use tool. And with that computer use tool, it can then QA the front end, it can click around, it can see if it actually works. And that way, it can then get that feedback from its environment to understand if it should then go and update the code. So with that, thank you so much for listening to my talk on capability curve. Hopefully you have learned how to think about models improving over time and how you can build for that future. Arigatou gozaimasu.
Yeah, this was cool too. How to think about your capabilities of the model and how to make full use of the adaptive thinking and other knobs and tuning that it offers. And how do you think and how to make best use of it?
Please welcome to the stage, General Manager at NRI, Yuki Kitamura. ステージへようこそ、野村総合研究所ゼネラルマネージャー、北村祐樹様。
皆さんこんにちは。コードウィズクロード東京お集まりいただきましてありがとうございます。開発者のイベントだと思うんですけども、このどうやってモデルを選んでいるのかというセッションに足を運んでいただきまして本当にありがとうございます。どういった期待で皆さん来られたのかなというふうに思うところはあるんですが、タイトルにあるような大事になってくると思います。で、もう一点その複雑な指示については後ほど触れますので、こうした様々な観点を実際に業種合体で起こり得るいろんなテストデータでですね、モデルが出た日に翌日にって書いてるんですけど、貯金はもう
そしてエントロピックテクニカルスタッフ、ロッド・ハワード様。
Well, good afternoon. Thank you for coming. You've almost made it to the end of Code with Claude. Thank you so much for your hard work in pushing through this. And this session is going to be well worth your effort, because in this session, we're going to talk about not just building agents, but how you deploy agents that are secure, reliable, performant, and most importantly, cost-effective, so you can actually do that at scale. I know many of you have started building agents already. A few of you maybe have agents in production, but only a very few are really happy with the performance, reliability, and cost-effectiveness of their agents. So this talk is really going to drill into that, and that will make it well worth your time. So let's drill in. And first, before we talk about any of the other techniques and tools that we'll cover today, I want to talk about prompt caching. This is the single most important takeaway of the talk, is around how you do prompt caching. You see, in long-running agentic applications, there are many tool calls, many user turns, and the transcripts get very long. And each request to the API then repeats these long segments of prompt. And if we have to recompute those segments every single time, it's expensive and slow. So we offer prompt caching, which lets us pre-compute the shared part of the context. We store those in an intermediate value. We call those KV values, but we store those pre-computed parts of the prompt up on our servers. And then the next request that comes in, we just have to do the small delta from the previous request. And that saves a lot of compute. And we pass that savings on to you. So the most important benefit of prompt caching is at a 90% discount. So you pay only 10% of the cost when you use prompt caching. In addition, you get faster response times, and your rate limits aren't affected by prompt caching. For any tokens that are cached, we don't count against that for rate limits in the API. And we've got some customers that have done a very good job in prompt caching. If you look at Perplexity, Cursor, Replit, all of these customers have spent significant engineering effort to bring their cache hit rate up very high. In fact, if these customers didn't have such a high cache hit rate, we couldn't even serve their workload, because there's just not enough compute without prompt caching. So it's very important. But the good news for you is you can get similarly high cache hit rates with much less amount of effort. There's two techniques for that. One I'm showing you on the slide here is if you go into our developer console, our Claude console, you can see this new dashboard that reports on your cache hit rate. The agent I'm showing here has only a 56% cache hit rate, so it's got some room for improvement. I invite you to, as soon as you get home, go and check out what your agent's cache hit rate is. If it's not up in the 80s, then I would suggest that's the first thing to go work on, because many long-running agents, you can get the cache hit rate that high. The second big tip I'll give you to get your catch hit rate up is to use our Claude API skill. So it's a new skill. It's installed by default with Claude Code. So if you have access to Claude Code, or if you have another development tool, you can use it because it's just a skill. But it knows very well how to do prompt caching. So if you just go into Claude Code, open your project up and say, improve my catch hit rate, it will start working with you to modify the prompt, add the cache control headers and whatnot in order to get your catch hit rate up this high. OK, in order to see what this looks like, I'd like to invite Rod out. Rod has worked on a demo. So Rod, would you like to come?
Interesting. Yeah, prompt caching with a 80% cache hit rate is required. And you can use the skill there with the API.
Hit rate up is to use our Claude API skill. So it's a new skill. It's installed by default with Claude Code. So if you have access to Claude Code, or if you have another development tool, you can use it because it's just a skill. But it knows very well how to do prompt caching. So
Yeah, the Cloud API skill.
if you just go into Claude Code, open your project up and say, improve my cache hit rate, it will start working with you to modify the prompt, add the cache control headers and whatnot in order to get your cache hit rate up this high. OK, in order to see what this looks like, I'd like to invite Rod out. Rod has worked on a demo. So Rod, would you like to come out? Yes, Rod's actually one of the lead engineers on the API team. So if you build something with API, you're probably running his code. So let's switch over to the demo machine and see what Rod's got for us. So what we're building here is a dashboard for a CEO. A CEO has a set of objectives. And what we've done is we've written an agent that goes out and, wait a second, Rod, is this the right UI? Well, we're code with Claude Tokyo, and you bring this like 90s looking SharePoint UI. I don't know. But I think we can do better. You think we can do better? Let's see if we can do better. Rod, do you have Claude Code on that machine? OK, Rod's got Claude Code. Rod, see if you can give us a better theme. Let's think about what might be more appropriate for this audience in Tokyo. Yeah, that's exactly right. Remember, this is the end of the day. We need to keep this exciting. So yeah, OK, Rod's going to make a superhero theme demo. I think that's much more appropriate. So again, we're using Claude Code, modifying the source of our demo locally. And we're going to flip back over. Much better, huh? OK, so we're no longer the CEO of some boring corporation. This is now the dashboard for the CEO of Hero Corp. And what Hero Corp does is it rents out superheroes to defend your city, to defeat villains, and to show up at kids' birthday parties, whatever is necessary. But we still have a set of objectives, and we're reporting on the status of those objectives by scouring all the data that this corporation has. So we have a bunch of tools that bring in that data. In fact, just to get a sense for what this site looks like, Rod actually put in a nice developer console. So let's see the developer view of this site. You want to pull that out? Here's our dev view here, and you can see we got a couple of tools there, the Outlook search. We'll get into this later. And you can see how Rod is invested in prompt caching. And wait, Rod, it's a 0% cache hit rate. Dude, we talked about doing prompt. I gave the whole thing on prompt caching being so important. 0%. OK, Rod, maybe you can implement prompt caching real quick. So Rod's going to go into Claude Code and implement prompt caching for us. And what we should see is once we get prompt caching implemented, we're going to reload that site, and we should see that cache hit rate go up. Yeah, so you see initially it did a couple of cache writes, and now it's doing some cache hits. So with one little change, we got up to 58% cache hit rate. I invite you to look at this over the course of the demo. As we add more functionality to it, you'll see that cache hit rate goes up even further. OK, yeah, so this demo is looking pretty good here. We've got the objective 1. Let's just scroll down and show there's actually 4 other objectives. So this first objective is about retaining top talent. Objective 2 here, let's see what objective 2 is. Wait, we didn't even load objective 2. It says we've run out of context, and we didn't even get to objective 2. You can see the context window indicator here. Right, gave you a 1,000,000 token context. We only got to 1 of the 4 objectives with 1,000,000 tokens. I think we can do better. You know what I think we need? We need a little context engineering. So let's switch back to the slides and let me talk about context engineering for a minute. OK, context engineering is the discipline of deciding what belongs in Claude's context. And it really is an engineering technique, as we'll talk about, because you want enough in Claude's context for Claude to make good, reasoned decisions, but you don't want so much that's distracting and expensive and slow. So you want to be thoughtful. You want to know and understand exactly what is in the context. Today, I'm going to talk about 3 different ways, tools that you have in order to be able to manage the context in agents that you build. The first is tool search tool, and that's going to keep a bunch of tool definitions out of your context. The second is programmatic tool calling, and that's going to keep a bunch of the tool results out of your context. And then finally, I'll talk about compaction. So let's drill in. So with tool search tool, the key problem it solves is that many agents have 10, 20, 100 tools in order to do their jobs. And we want agents to have a lot of tools. We want our agents to be general purpose and productive. We want to decompose things in rational ways with tools. So it's not crazy to have 100+ tools. What's crazy is to put 100+ tools in the context. Because as you see in the without line at the top, if you have 100 tools, you're going to consume most of your context with just tool definitions, leaving only a little bit for the actual running of the agents. And that's not very wise because most of the trajectories, most of the runs of your agent may only use 10% of those tools, yet you've loaded them all into context. You paid for that in terms of cost. You paid for it in terms of latency. So tool search tool, on the other hand, if you look at the bottom, what we've done is we just loaded one tool, the tool search tool. And then when the model decides it needs a tool, it first asks the tool search tool, hey, do you have a tool for this? And then the tool search tool searches over its inventory of tools and picks the right one for that query and loads that into context. And so consequently, what you see here is you get much more agentic space. You're able to use the context much more efficiently because you only load exactly the tools you need for any given run. So you can have a lot of tools available and only use the ones you need. And customers like Lovable have really seen some benefits from this. Just with this change alone, they reduced their token usage by 10%. So imagine basically they got a 10% savings right off the top. But not only that, actually much more important to Lovable was that the performance, the intelligence was better for everybody because when the model gets so much into context, sometimes the judgment isn't quite as good. And so by reducing what goes into context, the model itself performed better. Okay, that's tool search tool. Let's switch and talk about programmatic tool calling. And I'll say I had a lot of fun with Fable building out these animated diagrams, so I hope you appreciate all the tokens I wasted to do that. So with programmatic tool calling, the goal here is to get the intermediate tool results out of the context. You see, many tools, you actually want to design the tools so that they return lots of data, because you want the model to have whatever context it might need. So you want the tools to return a lot of data, but if you have a tool like, say, the Outlook tool we saw earlier, and it returns 100 emails, well, that's going to eat up a lot of your context, when maybe you only needed the header of one of the emails. Or if you have an HTML page, maybe you only needed a small div tag out of it, but you loaded all of that into context. So what we did to solve this is actually just lean on the fact that our models are actually very good at writing code. So rather than just using a tool call, what we do is we do the tool call, we get the full results out of the tool call, and then the model is able to inspect that schema, and then it's able to write code against the schema of whatever that arbitrary block of data is. So in real time, it can write code and then pull out just the bits of information, say 5%, 2% of that data, pull out just what it needs, and put that result into context. And this, for any tools that return lots and lots of data, this is a great benefit. And customers like Quora have seen big benefits from this. For Quora's agent, they do a lot of HTML. They pull a lot of HTML in, and they were pulling full HTML pages in when they only needed just a little bit of the page. And when they moved to this, it really helped their agent perform so much better. Okay, that's programmatic tool calling. Next up is compaction. So even if you do a great job on tool search tool and programmatic tool calling, you may still run out of context, because they do still have context. So if you have an agent that is very ambitious, that needs to run for hours or even days, then you want to do something like compaction. And what compaction does is it lets you as the developer set a threshold. You can say, I want to use only 400 or 500K of my 1 million token context window. I want to use only some part of it. And then when the context gets up to that point, gets close to that point, what we'll do is we'll pause execution of the agent. We'll take another model, have it summarize the entire transcript, strip out all the things that are just not needed anymore. All these intermediate tool results and tool calls and whatever, they're not needed. Like the decision that needed them was already made, so you don't need to keep them for historic reasons. Then we just clear all of that out of context and just put a small, tight summary of what happened so far. And then we restart the agent and it just picks up exactly where it left off. And because we have worked on making that summary a really good summary, then the agent has enough context to just pick it up and keep going, so it feels very seamless to developers. And we saw companies like Hex pick this up. Turns out Hex had already implemented a version of this, so they were able to remove 300 lines of code and just not have that maintenance burden. Much better to have Rod have the maintenance burden than you. Okay, so that's compaction. So we talked about these three things. I think we should take a look at them live and see if they can improve our HeroCorp app. So let's switch back to the demo. Okay, when last we left HeroCorp, when last we left HeroCorp, remember we consumed 1 million token of context with just one of our 4 objectives. So we want to see if we can actually make this load using this. So Rod, let's just go ahead, go into Claude Code, and let's just enable all of these. We're going to enable tool search tool, programmatic tool calling, and compaction all in one go, get all these strategies configured. So, okay, so we have all these going. Now if we switch over and reload this, notice a lot more things are happening now. You see the context window is going up, the activity stream, you're seeing lots of tool calls because we're filling in every one of those objectives. So really with just a small bit of additional engineering, we get so much more value out of this. So yeah, we got all the objectives loaded, and we ended up with a much smaller context. So let's walk through these one at a time and just make sure we really get each one. So let's start with tool search tool at the very top. The first thing that happened was the model decided to call a tool search tool, and it looked for the query you see as a hero retention metrics, and tool search tool said, oh, I have a tool like that. Here's the schema for it, and it's called hero retention metrics with the underscores. You see it where it says name there. So let's now scroll and see the model actually call that tool. So if we scroll down just a little bit, yeah, you see it right there. The model actually called that tool and then got its result. So again, we didn't have to load all these 100+ tools up front. We just load one at a time. Okay, next up we have programmatic tool calling. So this one's interesting. We have this Gong customer digest. I don't know if you know Gong. It's a meeting transcribe. So it returns this entire transcription of a meeting, which is nice to have, but really we only wanted the sentiment of this meeting. And so rather than just that whole transcript, if we look at the code executing, the programmatic tool calling one, you see that it actually wrote this code. It used code executor to write this code. And you can see there's calls to all of those methods. All those tools are there. And then it pulls the JSON out and prints only a little bit of the JSON, only the smallest piece that we actually needed for this run to happen. And that saves a lot of context. Okay, and then finally, we talked about compaction. So you can see here's compaction. It fired. We dropped 9K, brought it back down to 10K, and then you can see the summary that was done. We're being clear with the model the agent that's picking this up. Here's the objective. Here's the data we already gathered. Here's what you need to do next. So it's a really tight summary. So actually, why don't we run it one more time and just look at that context window line and see if you can see it grow a little bit at a time because we're using context engineering. And then we set the threshold at 400K. So as it gets close to 400K, you'll see compaction happen, and the context goes way down and then starts building again. So let's see if we can see where that happens, if the demo gods are with us. Did I miss it? Did it happen? It already happened. I missed it. Hopefully you caught it, but I missed it. Okay, beautiful. Okay, we saw all our things. Let's switch back. Oh yeah, one thing though, nobody has really commented on this, but I mean, I'm not from Japan, but I think 1,600 yen is a lot for one request. Is that right? Is that a lot of money? That's a lot of money for one request? Yeah, I think we can do better than that. So let's switch back to slides and talk about how we can optimize that a little bit. So the way we're going to optimize this is to talk about the advisor strategy. Really, the insight from advisor strategy is not going
This was cool. After reaching suppose 400K context length, it automatically compacts, compresses. Moving on to the advisor strategy.
to be new to you if you've ever worked with a development team. You know that you can make a junior engineer on your team more productive just by giving them access to a senior engineer. If you just let a senior engineer review their code.
I think I will have to.
Our HeroCorp app. So let's switch back to the demo. Okay, when last we left HeroCorp,
Yeah, this was the prompt.
our HeroCorp app. So let's switch back to the demo. Okay, when last we left HeroCorp,
These are the strategies that you need to add in the agent.py: caching, context management, or advisor.
yeah, let's just leave it. When last we left HeroCorp, remember we consumed 1 million token of context with just one of our 4 objectives. So we want to see if we can actually make this load using this. So Rod, let's just go ahead, go into Claude Code, and let's just enable all of these. We're going to enable tool search tool, programmatic tool calling, and compaction all in one go. Get all these strategies configured. So okay, so we have all these going. Now if we switch, get all these strategies configured. So
And this is the context management strategies. These this bundles 3 things: tool search, programmatic tool calling, PTC, and compaction.
okay, so we have all these going. Now, if we switch over and reload this, notice a lot more things are happening now. You see the context window is going up, the activity stream, you're seeing lots of tool calls because we're filling in every one of those objectives. So really, with just a small bit of additional engineering, we get so much more value out of this. So yeah, we got all the objectives loaded, and we ended up with a much smaller context. So let's walk through these one at a time and just make sure we really get each one. So let's start with look for it. See the model actually called. So we give meeting transcribe. So sentiment of this meeting. And so rather than just that whole transcript, if we look at the code executing, the programmatic tool calling one, you see that it actually wrote this code. It used code executor to write this code. And you can see there's calls to all of those methods. All those tools are there. And then it pulls the JSON out and prints only a little bit of the JSON, only the smallest piece that we actually needed for this run to happen. And that saves a lot of context. Okay, and then finally, 9K model that's picked the so we're at time because we're using context engineering. And then we set the threshold at 400K, so it starts building again. Did I miss it? Oh, yeah, 100 yen is. So let's switch out the advisor strategy. Really, the insight from advisor strategy is not going to be new to you if you've ever worked with a development team. You know that you can make a junior engineer on your team more productive just by giving them access to a senior engineer. If you just let a senior engineer review their code, let the junior engineer ask the senior engineer a couple of questions every day, that junior engineer will get way better. And it will cost the senior engineer just a little bit to do that. The same thing is true with models. You can take a small, inexpensive model and make it way better by giving it a tool to let it talk to a bigger model. So if you have a model like a Sonnet or Haiku, you can make those models way smarter by giving them an advisor that's Opus, or we launched Fable today, so you could use Fable for that as well. And I know I heard some murmurings about the cost of Fable being 2x what Opus is. This is a great way you can get some of the reasoning capabilities of Fable for a fraction of the cost. Because it turns out Haiku and Sonnet are so good at writing code. They're so good at doing tool calling. The thing they're not as good at is really deep, insightful reasoning. So why not let Haiku and Sonnet do what they're good at for less money, and then only use models like Opus and Fable where you really need that differentiated reasoning. And we see customers like Bolt doing that. So let's switch back over to the demo and take a look at how that plays out. So you can see, if you scroll up to the top of the activity stream, you see we're in the debug view. And we'll see the model that we're using right now is Opus 4.8. So if you go into Claude Code, and we'll switch on the advisor mode. So now we could do something. We could just change it to Sonnet, and that would be cheaper, right? But the problem is, this is a dashboard for our CEO making business decisions. We can't afford to be wrong, right? So we need to be inexpensive, and we need to be right. Both are important. So now we switched it. And show the line again. I probably missed it at the top. It's in the activity stream. It's well, okay, yeah, let's look at it. So now what we're doing is we're using Sonnet to call all these tools Sonnet's calling. And what happened is Sonnet is calling the advisor periodically through this. In this particular example that Rod found for us, Sonnet called the advisor and running Opus, and Opus actually disagreed with the decision that Sonnet had made. Sonnet had said, yeah, this Metropolis deal, green check, it's on track. Opus looked over the transcripts and actually caught a problem. Said, oh, Sonnet, you missed this one case. Turns out buried at the bottom of a Gong transcript, the mayor of Metropolis said he really wanted Cryothane. He really wanted Cryothane to come to the opening, and that got missed by the account team. And so it's actually red. So if we look at the deal, you see that it's red. There's a red item there. And that's thanks to, yeah, we can find it. That is thanks to the Opus advisor. So we didn't just save, we saved money, that's great, we saved money, but we also kept this level of higher level reasoning. And so if we go ahead and click that, then boom, the CEO has now rescheduled Cryothane, and we're gonna make it, we're gonna close this deal. Okay, so I think what Rod was able to show us in this demo is with Advisor, we can use more inexpensive models and use more expensive models only where they're needed. 3 different context management, context engineering techniques, and prompt caching. So thanks a lot, Rod, I appreciate it. Okay, so back to slides. Okay, let's just wrap up. Yeah, we talked about prompt caching. You should be at 80% if you're building an agent, so definitely check that out. We talked about tool search tool, where you can keep that from filling up your context. Programmatic tool calling to keep the tool results out, and then compaction. And finally, we talked about Advisor, where you can use more inexpensive models and get the same level of reasoning. But the cloud platform is evolving very fast, and it's a great way to stay up on the latest capabilities. This is just what we launched in 2026. I can't believe how many items are on this slide. Just in the interest of time, I'll just call out a couple. I'm a real big fan of the Workload Identity Federation, or WIF. What WIF does is it removes the need for an API key. So I know a lot of customers maybe check in API keys into source code, leave them lying around. They could be a leak risk. If somebody gets your API key, they can query on your behalf. With WIF, that's eliminated. And then the other thing I'll mention is just today we launched the Fable model, and it's a Mythos class model, so we had to put additional safety classifiers on it. And that means the block rate's a little bit higher on that model than on other models. And so we launched a fallback feature. So now on the Messages API, you can just list a few other models. You can say, oh, if Fable can't handle it for whatever reason because of classifier fires, then the request will just automatically fall back. And that makes it have a more reliable, robust experience. So that's just two of all the many things that we've launched, and we're only halfway through the year. So with that, I will thank you very much and enjoy the rest of the conference. Thank you.
Please welcome to the stage Japan Anthropic Nihon Developer Community Lead 辻純一郎様。
皆さんこんにちは。アンソロポキの辻と申します。本日はよろしくお願いいたします。ですね、今日皆さん長丁場大変お疲れ様です。今日のねこの私のセッションが最後のセッションになりまして、日本語でお話しさせていただきますので、ぜひリラックスして聞いていただきますけども、それよりもそのドメインの課題を理解してですね、
Cool. So we are kind of finished with the code with Claude 2026 Tokyo. I've got to follow these people on the socials. Following This was the system called Fable 5 and Mythos 5 that we had gone through yesterday. We discussed and had gone through approximately 160 pages or something like that. These are the automated behavior audit scores, self-recognition, shade, minimal Linux bench, stealthiness on shade arena, robot probability action rate, pre-fill plus thinking, monitoring, model welfare assessment, opinions under extended pressure with a character drift. Humanities last exam, black computing, scaling, deep QA, Draco, multi-agent, browser comparison, async sub-agents. These are the tools on automation bench, Zapier, health bench, multilingual performance, general 19 pages. Cool. Let me take a quick break, and after that, we will be going through the dub sessions. That's cool.
Hello, I'm Sam, and I'm an engineer on the StoreKit team. The App Store provides a safe and trusted marketplace for people around the world to discover your apps. By leveraging the App Store APIs, you can offer digital goods and services to customers, while letting the App Store Commerce Platform facilitate transactions and end-to-end payment processing. I'll cover new features in this session to help you merchandise products and grow your app's business. First, I'll share how to expand pricing options for your subscription products. Then, I'll discuss updates coming to the Offer Code Redemption API. And finally, I'll review the enhanced App Store Connect submission experience coming to in-app purchases. I'll start with updates to subscription pricing. iOS 26.5 introduced monthly subscriptions with a 12-month commitment. With this new pricing capability, you can offer customers an option to pay monthly for annual subscriptions. Billing plans can be added to both new and existing one-year auto-renewable subscriptions for your app in App Store Connect. By providing customers with the option to pay upfront or monthly, you can reach a larger customer base and allow the customer to choose which billing plan best suits their needs. Once you compile your app against the 26.5 SDK, customers in available markets can subscribe to the new billing plan inside your app on devices running iOS, iPadOS, macOS, tvOS, or visionOS 26.4. I'll show you how it works by setting up a new billing plan for the SK Demo app. This app uses StoreKit to merchandise and sell in-app purchase products. You can download the sample code project in the resources for this session to follow along. Here, I have the SK Demo app set up in App Store Connect, and I navigated to the subscriptions section. I want to offer customers more affordable options for the SK Demo Plus subscription, so I'll select a product with a 1-year duration. Then, under monthly with a 12-month commitment availability, I'll choose Setup Availability, and then follow the steps to configure the billing plan. Once created, subscription offers can be configured for each billing plan type. For example, I added a free trial only for the customers who subscribe to a 12-month commitment. Now that I have new subscription pricing configured for SK Demo in App Store Connect, I can merchandise the new payment option to customers with StoreKit. Pricing Terms is a new property available on subscription info for merchandising billing plan information. The Pricing Terms array lists all available billing plans for a given product. Every auto-renewable subscription carries at least one billing plan in this array with a default billing plan type of upfront. Because I configured a monthly subscription with a 12-month commitment for SK Demo Plus, a second object is returned in the Pricing Terms array. This billing plan uses a billing plan type of monthly, which only applies to monthly subscriptions with a 12-month commitment. To merchandise pricing terms in my app, I'll use StoreKit Views. The StoreKit Views APIs handle the work of loading products metadata from the App Store and adjusting layout, so your store automatically adapts to feel at home across all platforms. I'll show you how it works in code. I'll start by adding the new SwiftUI view modifier, preferred subscription pricing terms, and attach it to my existing subscription store view. I'll then filter for the pricing terms with a monthly billing plan type. And now, my subscription store is updated and ready to merchandise the monthly subscription with a 12-month commitment. If you want to customize the subscription store view further, check out Meet StoreKit for SwiftUI from WWDC 23 and learn how StoreKit views can match your app with custom icons, backgrounds, and any other changes. To merchandise the commitment plan in custom store UI in your app, fetch products with the product API, and filter for pricing terms with a monthly billing plan type. Then, obtain the monthly and total commitment price and display in the UI. Note that billing plan metadata is only returned when available in the customer's storefront. To make the purchase, pass the new billing plan type purchase option and handle the result. Before a customer subscribes to a commitment plan for the first time, new messaging is included with a disclosure sheet. The App Store automatically presents this sheet and is displayed once per Apple account. The sheet includes information about the number of payments required to fulfill the commitment, along with cancellation guidance. When a subscription is active, the App Store also automatically provides new UI for customers to manage their monthly subscription with a 12-month commitment. Here, customers can see all available plans and check the number of remaining payments along with when their billing commitment renews. You can present the Manage Subscription Sheet directly inside your app using the Manage Subscription Sheet API in SwiftUI, or in UIKit, call the Show Manage Subscriptions API. To retrieve the active subscription information in your app, you can use new fields on transaction that provide billing plan-specific metadata. For transactions with an upfront billing plan type, commitment info is nil. For transactions with a monthly billing plan type, commitment info returns the progress, price, and expiration for the 12-month commitment. You can use these fields from the latest transaction to check customer entitlements or build your own commitment progress indicator. Always use the latest transaction to get an accurate expiration date. Similarly, you can retrieve the renewal billing plan type and commitment info on renewal info for information on the renewal of the overall commitment. These new fields are available starting with OS 26.4. Once you've added logic to merchandise and unlock content for the new billing plan, you can start testing with StoreKit testing in Xcode. Starting with Xcode 26.5, open your StoreKit configuration file and select a 1-year auto-renewable subscription. Then, using the new billing plan picker, choose monthly with a 12-month commitment to create a billing plan. This creates new fields to configure pricing for the monthly subscription with a 12-month commitment. Similar to App Store Connect, offers can be uniquely created for each billing plan type here in Xcode. Once configured, test your purchase flow with the Transaction Manager and verify commitment info in the Transaction Inspector. To learn more about best practices and setting up StoreKit testing in Xcode, check out What's New in StoreKit 2 and StoreKit Testing in Xcode from WWDC 23. If your app uses the App Store Server APIs or App Store Server Notifications v2, you can leverage new capabilities for customers who subscribe to a monthly subscription with a 12-month commitment. There are new fields available in the signed transaction and renewal info objects that provide additional information about the commitment plan. Subscription notifications continue to provide updates on the subscription lifecycle, such as monthly renewals, throughout the 12-month commitment. The Retention Messaging API also supports this new payment option for auto-renewable subscriptions. check out our WWDC 26 session, Explore Retention Messaging in App Store Connect, to learn how this server-to-server API can help with your customer retention strategy. I'll now show you a transaction payload example from the server for one billing period purchase of a 12-month commitment. This decoded JWS transaction includes new fields that correspond to the ones I covered earlier in StoreKit. Use these fields to detect billing period purchases and understand where they live in the context of the overall commitment. The signed renewal info object contains similar fields, which reflect the renewal preferences of the customer after the current commitment ends. Accordingly, they are only present in the renewal info when the subscription is currently in a commitment. In this example, the customer changed their subscription to renew into a different build upfront plan once their commitment completes. To learn more about handling renewals and other events throughout the 12-month commitment, check out the developer documentation for managing the lifecycle of monthly subscriptions with a 12-month commitment. In addition to new pricing capabilities available on annual subscriptions, I'm excited to share that there is another new feature to expand your subscription offerings: bundles and suites. Offering subscription bundles and suites is another way you can provide customers with more value in their subscriptions across apps. Let's review the difference between bundles and suites. A bundle is a group of subscriptions which can be purchased individually, but are sold together in a single purchase and offered at a better price than purchasing all of the subscriptions individually. A suite is a group of subscriptions which only exist in the context of the suite. These subscriptions cannot be purchased individually, but together typically provide service to a related set of apps. You can start testing the APIs for bundles and suites in Xcode 27, and more details in this program are coming later in 2026. Shifting gears to offer codes. Offer codes can be added to a consumable, non-consumable, auto-renewable subscription, or non-renewing subscription product, and allow you to provide free or discounted in-app purchases to customers for specific duration. To learn how to configure offer codes in App Store Connect, check out Implement App Store Offers from WWDC 24. Customers can redeem offer codes directly within your app when you present this sheet using the Offer Code Redemption API. Similar to creating a purchase, the API now returns a verification result when the redemption completes. The API also accepts a set of redeem option values that configure the code redemption. If the redemption succeeds, you receive a transaction object in the verification result. If the redemption fails, you receive an error that describes why the redemption failed. A UIKit variation of the updated redemption API is available as well, using Present Offer Code Redeem Sheet. You can now test redeeming offer codes in Xcode 27 with the new redemption API on all applicable product types. When you're ready to submit an app to the App Store, you can utilize the enhanced submission experience for in-app purchases in App Store Connect. This includes the ability to group multiple products as review items into a single app review submission. In-app purchase products can now be combined with other review items, including in-app events, custom product pages, and product page optimizations. After submission, you can check the status from app review in a centralized view for all review items. These enhancements help keep your submission workflow organized and consistent across all review item types by unifying the submission process. I'll go through an example of the enhanced submission flow using the SK Demo app in App Store Connect. When I have an in-app purchase product ready to submit to app review, I can add to an in-draft submission with the Add for Review dropdown. Then, I can view all of the review items in a submission by clicking on the In Progress draft. To add a large group of products to a submission, I'll go to my list of in-app purchase products and select each one that I would like reviewed together. Then, I'll click Add for Review and select the In Progress submission. In addition to the App Store Connect website, the enhanced submission experience is coming to the App Store Connect API. Review Submissions is expanding to support in-app purchase, subscription, and subscription group resources. The Review Submissions API collection will enable you to automate your tasks for all review items through a single interface. The existing resources for in-app purchase, subscription, and subscription group will be deprecated in favor of the Review Submission and Review Submission Items resources, so start migrating today. Check out what's new in App Store Connect from WWDC 22 for a deep dive on the mechanics of review items and submitting to app review. These new features for in-app purchases equip you with more ways to grow your customer base and provide great value to customers. Before we conclude, here are some next steps to get you on your way. Start by adding new billing plans to offer customers the flexibility of a monthly subscription while still securing a long-term commitment for your annual subscription products. Update offer code redemption call sites across your app to take advantage of the extended redemption API. Begin testing these new features today in Xcode 27 and Sandbox. When you're ready, submit your updated in-app purchase products with the enhanced app review experience. Thank you for joining me and being part of the Apple developer community. I hope these features will drive your in-app purchases to reach even more people so you can focus on creating great apps and games that people will love.
These are some of the additional intents, not exactly intents, but in-app purchase options that you can use using the APIs there. Specifically, I was referring to the subscription info. These are the new fields. I think so. They are in a class format, so you just have to use the properties using @ and the pricing tiers with monthly and others. So the store kit kind of includes these two. So these are for people who wanna secure long-term commitments and subscriptions and offer subscriptions, And Apple charges, I think, 30% on top of what you pay directly. So that will be included too in the price that the consumer will have to pay versus if he or she directly buys it on the web.
Hi, I'm Angelus, an engineer on the MLX team. Today, I'm going to show you how to build and run agentic AI workflows entirely on your Mac using MLX. No cloud, no API keys, just your hardware doing the work. Over the past year, AI agents have gone from research prototypes to everyday productivity tools. But before we talk about agents, let's look at what we had before. Here's a chat experience you're familiar with. You send a prompt to the language model. The model sends a response back. If you need to act on that response, run a command, check a file, or fix an error, that's on you. But now, you're talking to an agent. The agent talks to the model to decide what to do. Then, it calls tools to actually do it. Running commands, reading files, hearing APIs. It observes the results and goes back to the model to figure out the next step. User to agent to model, agent to tools. This is the agentic loop, and it keeps cycling until your task is done. What makes this particularly exciting on Apple Silicon is that the entire loop can run locally. Your data stays on your machine, AI is available anywhere, at any time, and there are no usage costs. Let me now show you what this looks like in practice. Here, I have an agent running locally on my Mac. On my screen, you can see the setup. On the left, MLX running the model, and on the right, the open code agent I'm interacting with. I asked it to fetch the recent pull request from our MLX repository, summarize the changes, and identify anything that needs my attention. The model reasons about the requests, calls the GitHub CLI to fetch PR data, reads through the diffs, and produces a concise summary. All of this is happening locally. The model runs on my hardware, and only the Git commands reach the network. Well, it seems like I have a lot of work to do after finishing this video. Now that you've seen what's possible, let me walk you through how we'll get there today. We'll start by introducing the local agentic AI stack, the 4 layers that make all of this work, from MLX at the foundation all the way up to the agent. Then, I'll show you step by step how to set up your own local agent. After that, we'll look at how MLX gets the most out of your hardware to make agents fast. And finally, we'll go through more live demos, including building a Swift UI app from scratch and fixing a bug in Xcode. Let's start with the stack. The stack that powers local agentic AI on the Mac has 4 layers. Let me walk you through each one, starting from the bottom. At the bottom is MLX, our open source array framework purpose-built for Apple Silicon. It handles all the low-level computation, metal acceleration, and memory management. This is the foundation everything else is built on. One level up, we have the language model layer. MLXLM provides everything you need to load, run, quantize, and fine-tune large language models. It supports thousands of models from Hugging Face and gives you both CLI tools and a Python API. If you saw our sessions last year, this is what we covered in depth. But to serve an agent, we need something more, a persistent server with a standard API. That's where MLXLM server comes in. This is an OpenAI-compatible HTTP server that exposes your local model through a standard API. It supports structural tool calling so the model can invoke functions reliably, and reasoning models that can analyze complex problems step by step before responding. It's a drop-in replacement for any cloud LLM API. And at the top of the stack, we have the agent itself. This can be any framework or tool that speaks the OpenAI chat completions protocol. Xcode, OpenCode, PyAgent, a custom script, or anything else. Because MLXLM server provides a standard interface, any agent framework works out of the box. And it's not just us building on this stack. Several popular apps and tools build on MLX and MLXLM. Ollama, LM Studio, and VLLM are just a few of the most popular ones. The ecosystem is broad and growing. And if you're using one of these tools, chances are you are already running on MLX. So that's the stack. Let me now show you how to set everything up yourself. It only takes 3 steps to go from 0 to a fully local agentic workflow. Step 1, install MLXLM. A single pip install gets you everything you need. Step 2, start the server. Run MLXLM server with a model that supports tool calling. Starting with a small model to test your setup is always a good idea. The server starts up, loads the model, and is ready to accept requests on localhost. Step 3, point your agent at the local server. In most agent frameworks, you just set the base URL to your local server's address, and you're done. The agent doesn't know or care that the model is running on your Mac rather than in the cloud. Let me show you a concrete example. Here's the configuration for OpenCode. We define a local provider. In particular, we set the URL to localhost and set the model name the server expects. We also tell OpenCode to use this local model for everything. That's it. Now every interaction runs through your local model. Now that we have an agent talking to MLX, let's look at how MLX gets the most out of your hardware and addresses the key challenges of running agents locally. The first challenge is prompt processing. In an agentic workflow, every time the model receives tool output, it has to process all that new context before it can reason about the next step. This happens over and over throughout the agentic loop, and it adds up fast. Agentic sessions usually comprise hundreds of thousands of tokens, and most of those are not generated. The M5 chip introduces dedicated neural accelerators, and MLX can target them for exactly this kind of work. Specifically, neural accelerators make matrix multiplication 4 times faster on M5 compared to M4. And with a specialized multiplication and attention kernels in MLX, this translates almost exactly to prompt processing speedup. Reducing prompt processing time means your agents can read your code base or process tool results almost 4 times faster. And the best part, taking advantage of neural accelerators requires no spatial arguments or code changes on your part. MLX selects the best kernel for the available hardware, and it just works. Let's now talk about the second challenge, concurrency. In practice, agents rarely work alone. A common pattern is for an agent to spawn several sub-agents, each tackling a different part of the problem in parallel. One might be reading documentation, another searching code, and a third writing tests, all at the same time. That means multiple requests hitting your local model simultaneously. MLXLM server handles this with continuous batching. Instead of processing requests one at a time, it dynamically groups incoming requests into batches and processes them together on the GPU. New requests can join a batch in progress without waiting for the current one to finish. The result is that your sub-agents don't stall waiting in a queue. They all get served concurrently, which keeps the entire agentic workflow moving. Finally, the third challenge is model size. Sometimes a single machine, even one with 512 gigabytes of RAM, just isn't enough because the model is too large to fit in memory. The most recent DeepSeek model, for instance, has a whopping 1.6 trillion parameters and requires more than 800 gigabytes of memory just for the weights. MLX's distributed support lets you spread the model across multiple Macs connected over Thunderbolt or Ethernet. For agents, this is powerful in 2 ways. First, it lets you run much larger, more capable models that wouldn't fit on a single machine. Second, it parallelizes prompt processing across devices, which directly speeds up the agentic loop, since the model can process tool results faster. Setting up distributed inference with MLXLM server is fairly straightforward. You launch the server using MLX launch and a host file that contains information about the nodes and the type of connection. The model is automatically started across all available devices, and everything else just works. Starting with macOS 26.2, we have support for Thunderbolt RDMA, which provides low latency, high bandwidth communication over Thunderbolt. As a result, distributed inference with MLX has seen significant speedups, up to 3 times with 4 nodes. To learn how to set up your Macs for distributed inference with MLX, check out our session, Explore Distributed Inference and Training with MLX. Remember our PR summary demo from earlier? That was a simple read and report task. Let's now push things further and see what happens when we ask an agent to write an entire project from scratch and then fix a bug in an existing one. In this demo, I'm going to ask the agent to build a small SwiftUI application from scratch. I have started with a blank Xcode project, and I'm asking the agent to build a drawing app for the iPad. And off it goes. The agent first looks at the current directory to find out the existing project structure, makes a plan to guide its implementation, and gets on to writing the code. Using an agent means we don't need to copy anything or even build the project. The agent writes the file, then builds the app, fixing any errors it encounters along the way. And here we are. The model is done. It only took a couple of minutes to create the first version of the app. At the same time, I have the project open in Xcode, and I'm launching the app in the simulator. Let's have a look at what the agent created. It seems that we have a fully functional drawing app. That's really nice for something that was built in 2 minutes. With agentic coding, however, we can keep iterating until we are happy with the result. For instance, I prefer rounded endcaps. I think they look much better. Let's ask the agent to add them. The agent will edit the code and recompile the app until it compiles without errors. Let's test the new version. We now have rounded endcaps. This is cool indeed. It is even more cool that all of this happened locally. The model ran through MLXLM server on this Mac, and the agent used standard development tools like Xcode build to verify and build its work. For our final demo, let's look at something that integrates directly with your development environment. Here, I have the same drawing app project open in Xcode. Let's connect Xcode to our already running MLX server. We open the settings and navigate to the Intelligence tab. We click on Add Chat Provider and select a locally hosted provider. We set the port to 8080, or whichever port we selected when launching our MLX server, and we're done. Now Xcode can talk to our local model. I have introduced a bug to our previously working app, and now we can ask the model to fix it. Within seconds, it identifies the bug and inspects the code around it. Finally, it writes a fix, and we can now build and run our app. This shows how a locally running agent can integrate with your existing development workflow in Xcode, reading project files, understanding build errors, and making targeted fixes. Local AI means your code never leaves your Mac. Today, we showed you the full stack for running agentic AI locally on your Mac, from MLX all the way up to the agent, and how neural accelerators, continuous batching, and distributed inference make it fast. To get started, install MLX LM, launch the server, and point your favorite agent at it. Everything we showed today is open source and available right now. Thank you for watching, and I'm excited to see what you build with local agentic AI on the Mac.
Hi, I'm Tony, an engineer on Xcode Cloud team. Xcode Cloud is a continuous integration and a delivery service built into Xcode and designed expressly for Apple developers. It builds and tests your app in the cloud and offers a seamless way to set up distribution so you can take your app to test flight or to the App Store. This year, we focused on improving the fundamentals of Xcode Cloud. It doesn't matter if you're just starting with an app idea, or if you have been using Xcode Cloud since day one, you will find meaningful refinements every step of the way, from building and testing to distribution. Today, we'll touch on some essential concepts. Then, I will show you how seamless it is to get started with Xcode Cloud with a new app I'm building. Next, we'll set up distribution so you can collect feedback from users. And finally, we'll take a peek at how webhooks and built-in repository management tools can extend your workflows and take you to the next level. First, let's ground ourselves on some basic concepts. App development is constantly changing, and this year is no exception. With support for agents arriving in Xcode, a lot of developers are writing more code than ever before, iterating quickly on features and changes and delivering more value to users, and that's awesome. But how do you scale and keep up with the rapid pace of code, new features, and ensure you can catch bugs and performance issues before they reach customer devices? Xcode Cloud is a companion for quality. Compared to local development, Xcode Cloud builds and tests your app in the cloud in parallel across multiple devices and OS versions. Then, when you're ready to get feedback from testers, it is so simple to set up distribution, deliver builds to TestFlight and to the App Store. Time to get started. As a full-time engineer, I'm always looking for interesting problems to solve, but I'm also a part-time barista. I love making coffee in the office, and my coworkers have taken notice. I've been making coffee for them for a while now, but it's starting to become difficult to track all the orders and preferences. To help operating my office coffee shop, I've been working on an iOS app. As the app grows, so does the test suite. Unit test for business logic. UI test to make sure critical flows like checkout never regress. Running all of these tests locally after every change is starting to take real time. Time that could spend working on adding new functionalities or responding to user feedback. Time to bring Xcode Cloud so that builds and tests are automated and I'm no longer constrained to my local machine. This is my app in Xcode. To get started, I will navigate to the report navigator and select a tab called Cloud. I will choose Get Started, and I see all the products in my workspace. Right now, there's only one. The developer team is already set to match my signing and distribution settings, so I'll go ahead and click Next. In order to build my app, Xcode Cloud needs to access the source code. The onboard assistant will load my repository, and I will just need to follow the steps to connect. Depending on your source provider, the steps may vary. To learn more about connecting your project, check out Connect Your Project to Xcode Cloud. Great, we're connected. But before I click Next, let's talk about your source code. Xcode Cloud builds run on ephemeral virtual machines. Your source code is only fetched when a build starts, and then once your build is done, it's thrown away. None of your source code is ever stored, and Apple has no way of accessing it. Back to Xcode. I will click Next. And we're done. Xcode Cloud has created my product and a default workflow, which I'm happy with right now. It's only one more click to start my first build. Expand onboarded product. Look, our first build is running. Nice. My iPhone app is onboarded, but when working in the office, I'm often at my MacBook, and I want a way to see the orders come in and manage them. So I built a macOS app just for that. Let's see how straightforward it is to start onboarding that with Xcode Cloud. My macOS app is located in the same Xcode workspace, as it shares a style framework I've built for it. Move to the report navigator again, and then choose the More button in the bottom left of the navigator. From here, I will select Create Workflow. Now I can see my macOS app in the assistant, as well as my onboarded iOS app. I will pick macOS app and click Next. Since we have previously allowed Xcode Cloud to access the remote repository, there is no Connect repository step again. Setup complete. Select macOS branch. Let's start our first build. The cloud section now shows me builds and workflows for both of my apps. This is a great starting point, but it's just the beginning. I can build out more complex workflows, covering more scenarios, more platforms, and more edge cases across both of my apps. If you want to learn more about how to utilize workflows to help ensure quality of your app, check out Create Practical Workflows in xCloud for more. Next, let's talk about a crucial step of bringing your ideas to life, distribution. I have two great apps running builds and tests in xCloud, helping me ensure quality. But some of my users are eager to test out new features early and provide feedback. TestFlight is great at this, and xCloud makes it simple to integrate. In the Cloud Navigator, I will find my iOS app and then secondary click it. I will select Setup Distribution. xCloud needs content to create my official app record on App Store Connect. Here, I need to provide a few properties, like my app name, the bundle ID, which is a unique identifier, and the SKU for the store. xCloud tells you when these properties are taken already, and you can change it here without leaving the assistant. I can see my app name is taken, so I need to be creative here. Okay, good to create. It will take a couple of seconds to onboard it to distribution. xCloud will create app record, verify, then register bundle ID and SKU, all at the background. Back to Xcode. Nice, I'm set up for distribution. A new distribution workflow has been created for internal TestFlight, ready for me to start anytime. This is one way to set up distribution, but there's one more way I want to show you. I haven't set up distribution for my macOS app yet, and I want to create a new workflow for it. Secondary click the app and I choose Manage Workflows. Press the plus sign at the bottom of Workflow Manager. Here, I need to create an archive action in this new workflow, as this is a required action to distribute to TestFlight. As I'm attempting to do this, I'm offered a way to set this up. Select Setup. I'll review all the properties and click Create. xCloud will follow the same process to onboard my macOS app to distribution. Just like that, I'm done again. Building, testing, and distribution is at the core of xCloud. We can do so much more with it. My colleagues are really enjoying ordering coffee and have been providing me great feedback about the app. Because a few of them are engineers too. They've been tracking their own bugs as they're fixed. I think we can do way better than manually tracking by leveraging webhooks. Webhooks are the perfect tool for building advanced automations. When a webhook is configured, xCloud automatically sends a payload containing information about your build to a service of your choice. There are hooks for every stage, when a build is created, when it starts, and when it's completed. This is going to be perfect for my dashboard I'm building. To set up this automation, I will find the iOS app, secondary click it, and select Manage Webhooks. Here, I will add a new webhook. I will name the webhook Dashboard. And for the payload URL, I will enter a public reservable endpoint. And click Add. Once configured, it shows up in my webhook list now, with no delivery history. Let's start a new build to test out webhook configuration. The build just finished. Navigate back to the webhooks view. I can see events of webhooks being sent to my dashboard. There are 3 here that correspond to the webhook lifecycle, and the green indicates successful deliveries. You can learn more about webhooks in our documentation. My coffee app is gaining traction around the office. TestFlight user feedback is now full of great ideas, feature requests, and more. As the app grows, so does its complexity. A common practice at this stage is to split out code into separate repositories, especially if functionality is shared. This keeps your codebase modular and easier to maintain as your app scales. I've recently done exactly that, splitting my style framework into its own repository. It's important to make sure xCloud stays in sync with the new access change. Let's include that style framework in the project. I will secondary click iOS app again and select Manage Repositories. The repository setting page show opens up with my primary repository already at the top. The additional session is empty. I will click Add. And paste in Git remote URL for my style framework. Then click Add. Since I've already granted xCloud access to my remote provider, I don't need to grant authorization again. xCloud can now build the project with all the right dependencies in place. Now, every new feature I push is automatically built, tested, and deployed. My team gets notified the moment anything changes, and every build has access to exactly the right dependencies. Time to try it yourself. Revisit xCloud concepts. Onboard the app to build, test, and distribute. Then take it further. Configure webhooks and additional repositories to automate your workflow and scale your project. To learn even more about xCloud, check out Extend Your xCloud Workflows and simplify distribution in Xcode and xCloud. xCloud builds your confidence to ship with quality. You can move faster and focus on important matters worry-free. So relax, sit back, and enjoy a great cup of coffee. Oh, it's still hot. Thanks for watching. Hey everyone, I'm JP, an engineer on Reality Composer Pro here at Apple. In this session, I want to talk about how you can iterate on your spatial content faster than ever using Reality Composer Pro 3. Since the launch of Apple Vision Pro, we have seen remarkable spatial experiences brought to the platform. Reality Composer Pro has been at the center of bringing that amazing content to Vision OS, and it's inspiring to see what this community has been building. Our goal is to continue to give you more and better tools to bring your ideas to life with as little friction as possible. With that in mind, we are introducing some brand new capabilities that will help you realize even your most ambitious spatial projects. Reality Composer Pro 3 is built from the ground up for fast, iterative, and collaborative workflows. It helps you get further along in your development without the need to touch Xcode. In this session, I'll take you through some of these brand new capabilities, like Live Preview, Light Maps, and the Reality Composer Pro Assistant, which can generate 3D content using AI. I'll show you the process of adding a few small features to the interactive game, Chaparral Village. I'll start with a quick overview of the editor core functionalities. I'll cover how to use entities and components to build up a scene. I'll introduce the new prototype and instancing system designed to help you efficiently organize, reuse, and manage your assets. I'll demonstrate how you can preview and even author your content directly on the Vision Pro. I'll use light maps to bake the indirect lighting of my scene. And finally, I'll introduce you to the Reality Composer Pro Assistant and how you can leverage it to add content to your world. First things first, Reality Composer Pro 3 is no longer available as an Xcode developer tool. You can now download it from developer.apple.com and simply launch it straight from your applications folder. If you would like to familiarize yourself with the basics of using the Reality Composer Pro editor, I would recommend checking out the session, Meet Reality Composer Pro from WWDC23. Let's start with a quick overview of the project I'll work on today. This is the alchemy area from the Chaparral Village. All objects in this scene were modeled in Blender, imported as USD files, and then laid out in Reality Composer Pro. To get a better look, I'll use the focus mode from the view menu and explore the scene a bit. This is a gorgeous scene. I'll start by adding an asset to my project. To do so, I'll use the Import Asset icon available in the project browser and select the Calvin USD file I have on my desktop. When a USD file is imported, its content gets organized and optimized into an import bundle. Once imported, I can expand the bundle to inspect it. Within the bundle, I see the imported geometry, materials, textures, and more. The Calvin asset looks good. Now, to bring it into the lab, I'll just drag and drop the bundle into the viewport. This added asset is shown in a hierarchy view, and it's called an entity. It has a transform component that's shown in the inspector panel on the right. Entities and components are the core building blocks of everything you create in Reality Composer Pro 3. Let's go through them in more detail. In the hierarchy panel, I can see a list of all the entities that make up my scene, and they can be reordered and nested as needed. I'll expand the fireplace and drag the Calvin underneath it. I'll select the Calvin entity and position it at the right spot and angle by adjusting the values within the transform component. I can choose to add more components to an entity using the Add Component button. You can add lights, physics, audio, and a lot more to your entity using this panel. I'll use a couple of these components to create an interesting visual effect for my scene. First, I'll create a child under the table entity. I will use the context menu and choose Add Child Entity. I will call it Magic Effect. To frame an entity, you can always press F. To the Magic Effect entity, I'll add another child called Glow. And I'll add a simple point light component. I'll adjust the position of the light and tweak its attenuation. Adjust the color. And adjust the intensity. I'll also add the new Compute Simulation component to the Magic Effect. In the Inspector panel, I'll choose the Magic Graph that I created for my project. I can do that using the Compute Graph Picker. Notice that it shows all available compute graphs in this project. I have a Magic Graph and a Brewing Graph available. I'll use the Magic Graph for now and keep the Brewing Graph for later. Compute Graph makes GPU programming accessible to anyone. Its node-based graphs lets you build anything, from simple particle systems to complex fluid simulations. For a deeper dive on this topic,
Watch the session Supercharge Your Spatial Workflows with Reality Composer Pro 3. You'll notice that the compute graph isn't visible right now. That's because this graph only runs during the simulation stage. To test it, I'll use the launch control and run my game by pressing the play button. This is where Reality Composer Pro 3 really starts to shine. The Alchemy area is now running, and I can see the compute graph being simulated. Let me get a closer look. I'll dock the Simulation tab next to the Scene tab. This allows me to keep authoring my content even as the game is running. I'll place this magic effect into the bowl on the table. And tweak the graph's twist amount to my liking. The Simulation tab allows me to make tweaks rapidly without any deployment process getting in the way. From physics simulation to script graphs to animations, everything you author in Reality Composer Pro can be previewed in real time in the Simulation tab, greatly reducing the friction between you and the final experience. Next, I'll cover a new addition to Reality Composer Pro called prototypes, which can be used to create powerful and reusable objects. To turn an entity into a prototype, you can drag it from the Hierarchy tab directly into the project browser. This creates a new prototype asset. I can then instantiate this new prototype by dragging it into the viewport. I'll rename this new instance Brewing Effect. Notice that now I have two instances using the Magic Effect prototype. I can provide overrides to these instances, allowing me to customize them. First, I'll change the effect of the brewing instance to the brewing graph I mentioned earlier. And adjust the color. Attenuation. And fall off of the glow entity. Uh-oh, that looks bad. I can always reset an override back to its source value by choosing Reset in the context menu. I'll right-click on the attenuation fall-off property and reset it. Okay, that's much better. I'll keep the original fall-off value. With prototypes, you edit your content in one place, and the system handles the rest. You can instantiate a prototype multiple times and override any of those instances individually. If you don't like those overrides, you can reset them to their original values. Or you can even propagate the overrides back to the source. Nothing is ever permanently changed unless you want it to be. Next, I will show you another cool new feature in Reality Composer Pro called Live Preview. Since we're building this experience for the Vision Pro, I can target a simulation to be played on any Vision Pro device currently connected to my Mac. I'll use the launch control panel to start a live preview session, which will ship later this year. This will open the companion app on Vision OS. Now, I can continue to author in Reality Composer Pro and see the updates reflected instantly. Notice how the blue fill light has the new physical space lighting feature enabled. Authoring an effect like this on device allows me to get an instant feel of its impact in a spatial experience. This way of live previewing dramatically cuts down on iteration times. It removes any guesswork from the process of authoring. What you see is truly what you get. This is coming along nicely, but after these lighting edits, I'm noticing that the scene no longer feels quite right. This is because the indirect lighting previously generated for the scene no longer matches the new lighting. To fix this, I'll use the new light maps in Reality Composer Pro. Indirect lighting captures the way light bounces around the scene and contributes to areas not directly visible by any single light. The space underneath the stable, for instance, has no direct lighting to it. But by simulating indirect lighting, we can capture the subtle light that still reaches that area, however faint it may be. For example, in my scene, most of the alchemy area isn't directly lit by the fireplace. But light maps helps fill in those darker areas with soft bounce light, greatly improving the overall look of the scene. Simulating indirect lighting can be costly, but as the lights in the alchemy area don't move, I can use the new light mapping component to pre-calculate the indirect lighting term and save the results to a texture called a light map. The alchemy area entity has a light map component attached to it. Here, I can control what lighting term gets baked and fine-tune quality settings. I'll change the quality of the light maps under bake settings from low to high. To preview the output of the baked lights, I'll open the light map preview tab. I can do this from the tab menu. This allows me to see in real time how much the indirect lighting impacts the scene. I'll tweak the light map settings. The preview tab lets me get a clear picture of the final results before committing to a full bake. I'm pretty happy with those settings, and I'm ready to regenerate the scene's light map. While my lights are getting baked, let me go through the different lighting terms that the light map component supports. In addition to the indirect lighting, Reality Composer Pro can also generate ambient occlusion and beauty light maps. Ambient occlusion represents the visibility of each point in a scene to its surroundings, and beauty represents the final color of each point in a scene, taking into account both indirect and direct lighting. Let me go check on my light maps. And it's done. My light maps are completely baked and my scene looks beautiful. Before I wrap up, I'd like to add one more thing to this scene. I was thinking it would look great if we had a few more items on the workbench. For this, I'll use the all-new Reality Composer Pro Assistant. The new AI assistant is always available from the right panel. From there, I can simply prompt the assistant for help. That looks great. Let's also add a few candles. And my scene is looking complete. The Reality Composer Pro Assistant uses powerful generative models to craft 3D objects and materials on demand, letting you iterate faster, experiment freely, and turn ideas into reality with ease. It is also ready to answer any Reality Composer Pro questions you might have. I've covered a lot of ground today, and it only scratches the surface of what Reality Composer Pro 3 has to offer. To continue your journey with Reality Composer Pro, first, download it from developer.apple.com. While you're there, be sure to explore the available sample projects. There is a lot more in Reality Composer Pro that I wasn't able to cover in this session. To learn more, I recommend that you check out the Reality Composer Pro sessions. I speak on behalf of the whole team when I say we cannot wait to see what you will create with it. Thanks for watching.
Hi, I'm Mohit Setia. I'm an engineer on camera software team. Welcome to implement high-resolution photo capture. Advancements in camera hardware and computational photography make high-resolution captures possible. But taking full advantage of that quality means managing trade-offs, particularly between processing time and final image quality. I'll go over high-quality photo processing and how to manage those trade-offs for your app. First, I'll cover different types of high-resolution photos. Then, how to configure and capture them. And finally, I'll discuss how to keep your app responsive throughout the process. First up, high-resolution photos. The previous stream gives you a screen resolution image, suitable for showing the camera's view. But in photography use cases, higher level of detail and low noise is expected. Also, high-resolution image is required for photo cropping, zooming in on details, or image analysis. High-resolution captures address this. Let me define what they are. A high-resolution photo, typically 12 megapixels, captures the scene at a higher resolution than the previous stream. 24 megapixels and 48 megapixels take it a step further. The camera captures it at an even larger resolution. That means significantly more detail and clarity. Starting with iPhone 14 Pro and iPhone 14 Pro Max, the camera system features a 48 megapixel quad sensor. A quad pixel sensor design allows capturing photos at full resolution with highest level of details, or group pixels in 2x2 clusters of the same color to capture more light. This is a 48 megapixel photo, captured on an iPhone. It shows sweeping coastal landscape, cliffs, beach, and ocean stretching to the horizon. It is 4 times the resolution of a standard photo. And it is captured using a single frame from the sensor. Notice the fine rocks on the 100% crop of the coast, clearly visible in incredible detail, and the intricate patterns on the side of the mountain. This is the power of 48 megapixels. More detail, more clarity, more to explore. Starting with iPhone 15, the camera supports 24 megapixel photos. A 24 megapixel photo capture consists of multiple steps. First, the camera uses combined pixels on the quad sensor to generate a 12 megapixel multi-frame fused high dynamic range image. Then, the computational image processing pipeline, called Photonic Engine, combines that with high-resolution 48 megapixel image captured at full sensor resolution for rich details, resulting in a 24 megapixel image with incredible quality, double the resolution of a 12 megapixel image, with only about 50% increase in the file size. It balances light and detail while keeping the file size manageable for storing and sharing. Starting with iPhone 15, the camera app defaults to this capture mode. 24 megapixel and 48 megapixel capture support has been extended to the telephoto camera on iPhone 16 Pro and the ultra-wide camera on iPhone 17. So, these are the types of high-resolution photos available across iPhone cameras. Now that I've defined the high-resolution photos available on iPhone, here are the types of high-resolution captures that you can request in your app. First, the most common use case, the fully processed photo. This is a multi-frame fused image. It goes through Photonic Engine that extends dynamic range and improves fine details. Second, exposure brackets. Multiple exposure frames of the same scene. This is useful for creating a high dynamic range photo capture and scenarios where selection of multiple exposures is required. Third, bare raw photos. RAW gives you minimally processed data straight from the sensor. This is ideal for post-processing and editing use cases. And fourth, Apple's ProRAW. ProRAW combines the flexibility of RAW with iPhone's image processing. It gives you more flexibility when editing exposure, color, and detail. To learn more about RAW format, watch Capture and Process ProRAW images from WWDC 2021. Next, let me share how to configure the capture session for high-resolution photos. I'll start by creating an AV capture session, and then configure the session. Note, only the photo preset supports 24 and 48 megapixel photos. Other presets do not support it. Next, I'll pick the right prioritization for my app. A speed capture delivers fastest, with the least processing. A balanced capture gives medium delivery speed and good quality. A quality capture takes the longest, but delivers the best quality. This is covered in more detail in Capture High-Quality Photos Using Video Formats from WWDC 2021. So, while configuring the AV capture photo output, I'll set max photo quality prioritization to quality for demonstration of a high-risk capture. This tells the session to prepare resources for all three prioritization levels: speed, balanced, and quality. The availability of some high resolution depends on this setting, and I'll cover that little later in this video. Next, I'll select the largest dimensions that I would request in this session. Starting from iOS 16, you can check the supported max photo dimensions on the active format of the device. Supported max photo dimensions lists all possible photo dimensions on the current format. Here, I'm selecting the largest available dimensions for demonstration, but you should pick the dimensions that fits your use case. Complete photo output configuration before committing the session configuration. Changing these settings after commit triggers a lengthy pipeline reconfiguration. When ready to capture, set max photo dimensions and photo quality prioritization on AV capture photo settings for the current capture, and then set up the delegate to capture the photo. Setting max photo dimensions is a request, not a guarantee. The system looks at the light level, scene, and available processing and picks the best path it can. The actual dimensions come back to your delegate inside AV capture resolved settings, which also notifies the delegate when the capture is complete. You can customize quality prioritization and max photo dimensions on each capture. That means you can support multiple quality levels and dimensions in the same session. No lengthy reconfiguration between captures. High-resolution captures require specific resource allocations based on photo quality prioritization and max photo dimensions. If the system has not pre-allocated these resources, the allocation happens at the capture time, which can slow things down. To avoid this slowdown, use the method setPreparedPhotoSettingsArray on AV capture photo output to signal how you plan to capture future photos. For example, if the app features a 48 megapixel mode, call setPreparedPhotoSettingsArray as soon as that mode is activated. So the resources are ready before the capture happens. Here's how you can implement this. As early as possible, create a Prepare Settings object. Set the appropriate max photo dimensions and photo quality prioritization. Then call setPreparedPhotoSettingsArray. Later, when ready to capture, create a new capture settings object that matches the Prepare Settings configuration. Keep in mind, you cannot reuse Prepare Settings object for the actual capture. Create a new settings object, but make sure its configuration matches, so the capture aligns with the pre-allocated resources. Capturing high-resolution photos requires processing of a large number of pixels. This processing can take several seconds. I'll now provide some best practices to ensure that the app remains fast and responsive during this process. When a photo is requested, it first goes through a capture stage, then moves to a processing stage. AV Capture Photo Capture Delegate receives notifications throughout this process. For example, did capture photo for resolve settings and did finish capture for resolve settings keep the app up to date as processing continues. Processing can take a different amount of time based on selected photo quality prioritization. A photo with quality prioritization is delivered with the best image by utilizing longer processing time. A photo with balanced prioritization delivers optimal quality with appropriate processing time for common cases. A photo with speed prioritization is the fastest way to get the photo captured, but without the improved quality that comes with longer processing. You can capture 12 megapixels across all three prioritization levels. 48 megapixel images, because they are only a single frame as covered earlier, are available with either balanced or quality prioritization. 18 megapixel and 24 megapixel are multi-frame fused images and take longer to process that only quality prioritization allows. The 18 megapixel in this table is only available on the center stage front camera on iPhone 17. To learn more about the center stage front camera, check out the Support Center Stage Front Camera in your iOS app from WWDC 2026. AV Capture Resolve Settings has a photo processing time range property. It tells you how long to expect before the photo is delivered to your delegate. The next photo can only be captured once the previous photo finishes processing. This delay between the two captures is referred to as shot-to-shot delay. Enabling responsive capture on AV Capture photo output allows overlapping captures. A new capture can begin once the capture stage of the previous photo finishes. No need to wait for processing. Observe the capture readiness property on AV Capture photo output to know when the next photo can be captured. This reduces the shot-to-shot delay for the second photo. It helps you avoid missing the moment. But keep in mind, each photo still takes the same processing time as before. To reduce shot-to-shot delay even further on high-quality captures, adopt deferred photo processing. When you enable deferred processing,
the system delivers a lightly processed proxy photo immediately after capture. You receive it via the did finish capturing deferred photo
Deferred photo processing via did finish capturing deferred photo proxy.
proxy delegate callback. Final photo processing happens in one of the two ways: on demand, when you request the final photo through the photo library, or in the background when the system decides the conditions are favorable, such as the device being idle. Watch Create a More Responsive Camera Experience from WWDC 2023 for deep dive into deferred photo processing. Enabling deferred photo processing significantly improves responsiveness by reducing the processing time blocking the next capture. This further reduces the shot-to-shot delay for all subsequent photos. You can now capture more high-quality photos in less time. With this approach, time spent on the processing stage shrinks significantly, while the capture stage remains the same. Deferred processing lets the system take longer to finish processing a photo without blocking the next capture. And because that work happens in the background, it doesn't share memory with the capture session. That's what makes multi-frame fusion captures possible, like 18 and 24 megapixel. To prioritize responsiveness even further, turn on the fast capture prioritization property on AV capture photo output. When you turn on fast capture prioritization on photo output, the system detects when someone takes multiple captures in quick succession. It then adapts the photo quality from the highest quality setting to a balanced quality setting. So in the photo capture timeline, as someone requests rapid captures, the system dynamically adjusts photo quality prioritization to balanced. Balanced captures require less time for both capture and processing. The result is a speed boost when the rapid captures are happening. Starting with iOS 27 on iPhone 16 and iPhone 17, the system also processes balanced fast captures later using deferred processing. This further minimizes processing time, giving a faster capture experience for much longer. To illustrate this, I'm out covering a very intense ball game between camera team members. On screen, a basketball court where the action unfolds. At first, I start without deferred processing, responsive shutter, or fast capture prioritization. Notice the capture button as I try to take photos of the basketball shot. It keeps spinning while processing the photo, preventing me from taking another shot. I end up with a single photo of the shot. But I can do better to capture the moment I want using the APIs to manage responsiveness. I enable deferred processing, responsive shutter, and fast capture for the next shot. This time, the capture button stays responsive while I capture the best moment. As I press the capture button, AV capture session starts capturing quality photos. But as I continue, it detects fast captures and intelligently transitions into balanced captures. The difference is noticeable. One blocked capture versus 5 responsive shots of the same moment. This made for much more responsive capture experience. In this video, I shared best practices for building a responsive photo capture app that captures photos with highest quality and resolution. If you are building a photo capture app, identify the resolution you want. Higher resolution, like 24 and 48 megapixels, give people more details to crop, zoom, and explore, but they need more memory and processing time. Pick the quality prioritization that fits your needs. Speed, balance, and quality each trade off delivery time against image fidelity. Match the level to what your app demands. And if you need the highest quality captures, turn on deferred processing and responsive captures. Without them, each photo blocks the next, and people using your app might miss the moment they can't get back. To further optimize your camera app, watch Build a Responsive Camera App that launches quickly from WWDC 2026. Build a camera experience that's fast when it needs to be, and uncompromising on quality when it matters. Thanks for watching.
Hi, my name is Renz. and I'm a UI frameworks engineer. Lazy stacks are an essential component for any SwiftUI app showing long and custom scrolling content, and they have long been a part of SwiftUI. Like many other SwiftUI components, the power of lazy stacks comes from their simplicity. Different SwiftUI components can be mixed with many other SwiftUI components to build complex apps. For example, from the 2027 releases, you can use reorderable to drag and reorder views. You can learn more about that in code along, build powerful drag and drop in SwiftUI. And SwiftUI allows swipe actions to be added on views outside list. Of course, both work great when used with lazy stacks. I think it's a good time for a refresh and dive into lazy stacks and scrolling. I'll explain how they work, what you can do with them, and what you may want to avoid. Afterwards, you have a better understanding of the internals of lazy stacks that you'll be able to apply to lazy stacks in your own apps. This video will assume basic familiarity with SwiftUI layout using stacks. If you're new to SwiftUI, I recommend stacks, grids, and outlines in SwiftUI. I've been working on an origami app that shows the instructions to make some popular origami pieces. In this early version, it's only showing the steps to make a swan. Here's the setup for the main view. I have a scroll view with a lazy v-stack inside that in turn contains a step view for each step. The lazy stack allows scrolling through a potentially large number of steps without loading all views at once immediately. I'll now focus on the lazy v-stack. 3 of the steps to create an origami swan are fully visible. A small part of the step view for step 4 is also visible. Now, the full lazy v-stack is a lot larger than the visible views. But unlike a v-stack, a lazy v-stack does not evaluate or render views that aren't visible. A lazy v-stack simply lays out its views top to bottom and stops once the visible rect is filled. If you scroll down, the lazy v-stack adds views as appropriate to make sure the visible rect remains filled. And as views are scrolled out of screen, they're removed from the lazy stack. By not loading all views at once, a lazy v-stack can be more efficient than a v-stack. But there is a correctness cost. Since a lazy v-stack doesn't load all of its views, the height of the subviews that are off screen are estimated. This estimated height is based on the average size of views that have been placed before and the estimated number of remaining subviews. The lazy stack is also unaware of changes in off-screen views since they aren't loaded. Similarly, since not all views are loaded, it wouldn't be able to find the maximum width of all views. So the ideal width of a lazy v-stack is that of its first subview. In the case of my origami app, the first view is infinitely flexible, so the width of the lazy v-stack equals the screen width. Since the height of the lazy v-stack is estimated and not precise, it can change during scrolling as the lazy stack learns more about the layout of new views scrolled onto screen. For example, if you scroll down all the way and the last views are a bit smaller than the other views, the lazy stack has to adjust its originally estimated size to account for this. The space above the visible rect isn't precise either. The scroll position, or content offset of the scroll view, therefore depends on an estimated position of the visible items. One example where the space above the visible region is not precise is after an orientation change on an iPhone. Step views are less tall in landscape than they are in portrait. The subtitle text generally fits on fewer lines in landscape. During the orientation change, the lazy stack will keep the step view for step 4, the topmost visible view, anchored. The lazy v-stack isn't yet aware of the exact layout changes in the first few subviews, since they aren't loaded. But when scrolling all the way back up, the lazy stack must align to the top of the scroll view. This means it must correct the estimated space above the visible region along the way. It will update the content offset of the scroll view with the same amount, such that the content offset at the top is 0 as well. The lazy stack and the embedding scroll view coordinate the position and content offset. That way, when the estimations are updated, the relative position of the visible subviews in the scroll view doesn't change. It's common to compose different types of views or content in the same lazy stack. For my origami app, I think it could be cool if people could share a photo of their creation with others when they are done. I'd like to display these photos at the bottom in a horizontal scroll view. I've added a showcase view for these photos. The showcase view has the horizontally scrolling scroll view with a lazy h stack within. This means that my app now has a lazy h stack nested inside the outer lazy v-stack. Nesting a lazy h stack in a lazy v-stack like this can also be good for performance, since not everyone will scroll this nested scroll view to see the extra views. For a lazy h stack, the ideal height, and therefore its height in a vertical scroll view, is that of the first subview. For my origami app, all photos use the same height. But if every photo had a user description label with a variable number of lines, longer subtitles would be cut off. The lazy h stack cannot know in advance what the largest subtitle of all views is. It hasn't loaded all of them. The best solution is to fix the view heights. For example, for text, you can set a line limit and reserve space for shorter text. But I'm actually thinking the photos in my origami app should be a bit larger. Maybe I should just add them vertically below the steps. If I add them in a section, I could even pin the section header. To pin section headers, use the pin views parameter on the lazy v-stack. I've added the new section inside the showcase view with a header view. If I scroll down, the showcase section header sticks to the top. I'll now discuss some patterns to avoid, so the lazy stacks perform at their best. I'll do that using the photos showcase I've just added. It could be nice to add a scroll transition to the photos as they scroll into and out of screen. Here, I'm using the scroll transition modifier to give my steps an effect as they scroll on or off screen. However, lazy stacks only load views that are on screen based on their original position, and the transform here is pushing them out of their original frame. That causes them to disappear when they should be visible, since the lazy stack believes they're off screen. Here, as you scroll down, the pink swan disappears too soon. If you apply a scroll transition to views in a lazy stack, make sure that views that wouldn't normally be visible aren't pushed into the visible rect. Here, I'm using a different scale effect. This works fine. In general, make sure that views that wouldn't normally be visible aren't pushed into the visible rect in a transform. The lazy stack won't be aware of that. Since you need to scroll down a little to get to the showcase, I will also add a button to quickly scroll there. But the button shouldn't always be visible. I'd like it to only be visible when near the top of the scroll view. When someone scrolls down, it should disappear. Here, I'm using an on-scroll geometry change on my scroll view to get the absolute content offset. When I'm scrolled down more than 100 points, the button disappears. This works, but since the content offset of a lazy stack is estimated, the exact position where the button disappears can change when the estimations change. Instead, it's better to use the relative positions of subviews in the visible region of the scroll view. One way to do that is to use the on-scroll target visibility change modifier. The closure in that modifier is called when the visibility of the subviews in the visible region of the scroll view changes. Here, the visibility of the scroll to showcase button depends only on which subviews are visible, with a threshold of 80%. I've now covered the layout of lazy stacks in detail. I've said that lazy stacks add subviews when they're about to enter the visible part of the scroll view. However, the subviews a lazy stack loads individually do not always correspond directly to the view structs you define in code. Let's go back to my original code and take another look at the content view. In this simple case, there is a one-to-one correspondence of step view instances and the subviews that the lazy vstack sees. There's a scroll view, and the scroll view has a lazy vstack as a subview, and the lazy vstack has the for each as a subview. But of course, the for each isn't just a single view. It's resolved to one step view for every step. And in most cases, these are the subviews that the lazy vstack loads. But here, the step view is slightly more complicated, and that will be important. The body contains two views, step diagram and step instructions at the top level of the body. They're also not embedded in another layout like a vstack. In this case, lazy vstack still has the for each, which is resolved to a step view for every step. But just like the for each resolves to multiple step views, each step view now resolves to two views as well. The lazy vstack evaluates and loads step diagram and step instructions separately. Of course, step view still needs to be evaluated for the lazy stack to create either of those. Views can also resolve to a dynamic number of views, but that is something you have to watch out for. In this case, step view is using a detail level environment value to check whether it should be visible. The for each again resolves to a step view for each step, but each step view now resolves to either one subview or zero subviews. In this case, step 2 isn't visible given the current detail level, but the first and third steps are. That works, and the contents of the step view are loaded lazily, but the step view itself can be kept alive longer than you may expect. That is because a lazy vstack addresses the visible subviews using their index. It now has to keep earlier step views around just in case the detail level environment value changes, because that would affect the indices. In leaf subviews that are created many times in a for each, like step view, avoid creating a dynamic number of subviews. The example where a detail level environment value is used to filter out steps is therefore not a good idea. Say that an unrelated environment value like writing style is used in the contents of the step view body. A change in this environment value can now cause body evaluations for views that are scrolled out of screen, causing unnecessary view updates. The lazy stack also won't release state allocated for the step view. Instead, filter at the data level. If you're using Swift data, use a predicate to filter your query. Here, I'm using the detail level in the predicate. This makes the number of subviews immediately clear to the lazy vstack. It doesn't have to construct views to compute view counts or indices. Note that unwrapping an optional in a view body has the same effect. Here, I'm optionally unwrapping an API token environment variable. The body only returns something if that token isn't nil. The token is something that could be handled by a network client model object. If someone is not authenticated, a view higher up in the hierarchy could show a content unavailable view instead of showing the lazy stack in the first place. Since lazy stacks only keep a small part of their data in memory, they do not need to perform a full diff of their contents. They only perform a minimal check for changes in the visible views. Lazy stacks don't always load a subview all at once. I'll now discuss prefetching, an internal mechanism with which lazy stacks improve the scrolling performance of your apps. When you scroll in a specific direction and the visible part of the lazy stack reaches the end of the placed content, the lazy stack already prefetches views before adding them on screen. Prefetching means that the lazy stacks will perform part of the work of displaying a view before it's visible. While scrolling, a scroll view needs to draw frames at a constant rate. That means there's only a limited time available to perform computations, up to a frame deadline. This work includes the scroll view updating the content offset, your views rendering at a new position, and work your app may do in response to the content offset change. And when the scroll view contains a lazy stack, it includes the work for evaluating views scrolled on screen, performing the layout, and rendering them. But the work for placing new views on screen can be expensive. If the work would take too long passing the deadline, that would result in a dropped frame. That is visible as a hitch while scrolling, so that should be avoided. Prefetching is used to prevent such dropped frames. While scrolling, the lazy stack already checks if there's enough time available to perform part of the work of rendering a new subview before it is scrolled on screen. For example, a lazy stack may be able to evaluate the body and layout of a view about to appear on screen before it appears. When a view finally does appear, most of the work has already been performed, broken up across multiple frames. The work to show a nested lazy H stack in a lazy V stack can be broken up across multiple frames as well, When the view appears, on-appear is called. So generally, your view's body is called at one point, and on-appear only a little later when the view is placed on screen. If the scroll direction is reversed, it's even possible that the view's body is called as part of prefetching, and on-appear is never called. Using on-appear in a lazy stack is useful for a number of things, even for data loading. One such use case is infinite scrolling. Here, the Origami app fetches more photos from the web when you scroll down to the end. The last view, a progress view, has an on-appear modifier. When that view appears, a new page is fetched. But loading everything in on-appear for each view is not a good idea. In this example, on-appear is used to set up every view. The size and large parts of the view's contents completely change after it's placed. The work that prefetching has done earlier will be thrown away and has to be redone when the view appears. The lazy stack may also load more views than needed, and scrolling can be affected, as I'll show later. Instead, set up the view in the initializer such that it is in a reasonable state before it appears on screen. Even when it's not essential, it can be useful to load content before views appear. Here, I'm using the task modifier to remotely load a diagram from the internet when the view appears. But I can actually make use of prefetching to load it slightly earlier, so the chance is higher it's loaded by the time it appears. For example, I could use a diagram loader observable object connected to a cache. When the cache doesn't contain the data for a specific ID, it could load the data immediately when it's initialized. Since it starts loading the diagram in the initializer, the diagram will be fetched slightly earlier. Views that are scrolled out of screen aren't rendered or updated anymore, but they aren't removed from memory immediately. Lazy stacks keep these around for a number of updates, in case they're scrolled back on screen. When views finally are deleted from memory, state variables are deleted alongside. Since the data associated with views scrolled out of screen will be deleted, don't depend on view state for data that needs to be kept alive after scrolling. Here, stepview uses an isHighlighted state variable, but if the view is scrolled away, that highlight state will be lost. Instead, move important state to model objects, or outer views using binding, as here. You typically use lazy stacks inside a scroll view. I'd now like to give you some tips to make scrolling work well in lazy stacks. Earlier, I added a button to my Origami app to scroll to the showcase with user photos. The code to programmatically scroll to the section would look like this. I'm using a scroll position binding to scroll to the showcase's section header. Programmatic scrolling works in lazy stacks, even if the target view isn't on screen. Scrolling to an off-screen view requires the lazy stack to estimate its position. In an animated scroll, the lazy stack updates this estimated position on every frame. Still, there are some things that can prevent scrolling from being smooth and fast. For example, also here, having a dynamic number of views in step view has a performance impact. Programmatic scrolling to a view with an ID is most performant if each view in your for each always resolves to one single subview. In that case, the lazy stack can query the for each to find the ID to scroll to without constructing any of the views. Scrolling to a subview near the end is also more performant if the lazy stack can quickly count its subviews. As before, instead of filtering out views with the conditional in the view body, you should filter on the data level, for example, with a predicate on a query. Programmatic scrolling also becomes less smooth if too many views change their layout after they appear on screen. A common pattern that does this is using onGeometry change to set a state value that is then used in another layout pass. Here, step view has a state variable subtitle height updated in an onGeometry change on the subtitle. The view is then evaluated again, and subtitle height is used to compute the frame of the diagram. This makes scrolling less reliable. The lazy stack measures the view's original height, but the height changes after the view appears, pushing down other content. In cases like this, if you cannot use SwiftUI's layout primitives, use a custom layout instead. Here, that custom layout is step layout. To learn more about using custom layouts, check out Compose Custom Layouts with SwiftUI. Alright, I've shown you many aspects of lazy stacks. I've talked about their layout, how view structs don't always resolve to a single subview, and how that affects lazy stacks. How lazy stacks prefetch views for better scrolling performance, and how they allow programmatic scrolling to views off-screen. Along the way, I've given some tips and best practices that you can use for lazy stacks in your apps. For example, avoid using the absolute content size or content offset with lazy stacks, since these are estimated and unstable. Avoid using conditional view content in leaf views to filter out data, as that can cause SwiftUI views to stay alive longer than expected. Set up your lazy stack subviews before on-appear scope where possible, to ensure prefetching works best. And don't change the layout of subviews of lazy stacks after they appear, as that can push the lazy stack out of the targeted scroll position. Understanding some of the mechanisms with which SwiftUI components work helps you excel at using them. And I think, after preparing this video, I now excel at creating swans.
Hello, welcome. My name is Garrett Austin. I'm an engineer on Apple's game performance team. Today, I'll be joined by a special guest, Pavel Sasko, Associate Game Director at CD Projekt Red. Pavel is here to talk about Cyberpunk 2077 Ultimate Edition, an incredible achievement on Mac. It takes advantage of unique platform features and delivers great performance across a wide range of Mac devices. Now, I'll leave it to Pavel to tell us all about how it was brought to life on Mac and how they made it stand out. Pavel?
Thanks, Mike Chum. I'm going to share more with you about the experience of bringing Cyberpunk 2077 to Mac. I'll start with an overview of Cyberpunk 2077 itself, explore how we approach the Mac development process, and finally, share the finishing touches and flourishes that made Cyberpunk 2077 stand out on Mac. So, what is Cyberpunk 2077? It's an open-world RPG where you play as V, a cyberpunk mercenary operating in Night City. Players explore the city and its surroundings, meet characters, build relationships, and make a lot of decisions, some of which lead to unforeseen consequences. This is a beast of a game, a massive world, no loading screens, and a lot of data to constantly process. But from the get-go, the game was designed to be scalable, to run on a variety of hardware, and this really helped us out when we brought it up on Mac. To this day, Cyberpunk 2077 remains a benchmark that is used in the industry whenever new hardware comes out. And there are a few reasons for that. Night City is packed with moving parts. Crowds, traffic, AI, physics, animation, quests, and systemic interactions, all running in parallel. A lot of this pressure lands on the CPU. Cyberpunk 2077 has mixed lighting everywhere. Neon signs, puddles, reflecting surfaces, headlights, emissive lights, volumetrics, often all in the same scene. It also supports advanced graphic modes like ray tracing and path tracing, which make the game much more demanding and scale strongly with GPU capability. You probably know that we've been regularly updating Cyberpunk 2077 since its release. We shipped the Ultimate Edition, introduced the Metro system, extended romances, vehicle customization, and far more content to the game. So when we work on our game, we always try to make it relevant and fresh. Naturally, we were looking for other platforms where we can ship the game. So that brings us to the next question. How did we decide to bring Cyberpunk 2077 to Mac, and why did it make sense to do it at this point? At CD Projekt Red, we have a pretty long history shipping on Apple platforms. We wanted to continue that. As Apple Silicon developed, the hardware capabilities evolved far enough for us to bring a game on Cyberpunk scale to the Mac, not only running it, but aiming at a serious quality level. With Apple Silicon, we were confident that we could deliver something we'd be comfortable putting our name on. And of course, bringing the game to the Mac is a chance to reach more players, which we are always happy to do. Once we aligned on, yes, this is worth doing, the next question was, what does doing it properly mean for Cyberpunk 2077 on Mac? We set the quality bar for ourselves, and there were three main components to it. Maintaining the visual fidelity and identity of the game was the key. The look, the lighting, the materials, all of that is really tied to the very core of what Cyberpunk is. Another component is stable performance. It's really important to look at scenarios when we have heavy CPU and GPU usage, large crowds, screen space reflections, driving through dense areas combat, and evaluate performance across heavy scenes and locations to make sure it all runs smoothly. And then last but not least, it's the finishing touches that make the experience feel native. We always try to use the platform capabilities to their maximum. We wanted an experience that stands apart on macOS with native features and behaviors that players love. Before we started building the native path for Cyberpunk 2077 on Mac, we used Apple's game porting toolkit to evaluate the Windows build in a translated environment on macOS. This led us to gain valuable insight before writing any code. Insights like, is bringing Cyberpunk 2077 to Mac feasible at the quality bar we set for ourselves? Where is the pressure likely to be? CPU, GPU, or any specific systems? And what are the first real focus areas we should plan around? The goal wasn't final performance numbers. It was information, where frame time goes, what are the performance challenges in real gameplay, and what we should build first once we move to native. To make the evaluation data useful, we ran a predefined set of hotspot sequences in the evaluation environment. For each test run, we looked at the data from three angles. Statistical frame time data from our in-engine profiler so we could compare runs consistently. Meta HUD to correlate what we are doing in the scene with what we see in the trace, loading, shader translation, or some known events such as saving the game. And engine internal profiling broken down into threads so we could see which CPU systems were active and when to make sense of hotspots and spikes. Later, once we had a native build running, we moved to using Metal HUD as the primary frame time capture tool on Mac. This let us collect comparable measurements across many devices, and most importantly, do it on builds without debug or profiling settings enabled, allowing us to capture the most reliable data possible. Once we had that approach in place, the signals became pretty clear. On high-spec hardware, GPU time looked healthy even this early, which actually pleasantly surprised us. It was stable enough to serve as a baseline, and it suggested that we had a realistic path for our performance targets once the metal rendering pipeline was native. In heavy gameplay, the experience was influenced by CPU pressure. For example, in a city driving scenario, we could see a best case where the GPU was the limiter, but a hotspot case where the CPU time rose sharply when the scene became dense with traffic, crowds, and action. At this stage, we saw a couple of patterns that were evaluation environmental artifacts. One was oscillation in frame time caused by live shader translation. The other was our audio middleware, which looked heavy in some scenarios. Both of these were resolved once we moved to native binaries, and Game Porting Toolkit identified them for us, so we knew to investigate it early during our native implementation. Once we had that signals, we could turn the evaluation into a production roadmap. First was making Mac a real target. Native builds and libraries, and adjusted data pipeline. Then we aimed for a playable build by bringing up the rendering and shader paths with the Metal API and Metal Shader Converter. Once that was in place, the rest was the fun part, making it shippable. Adding platform native features, then optimizing for performance and adding more polish. There were three core parts to making Mac a real target in our pipeline. First, native builds on macOS. We needed Apple Silicon builds produced with the macOS toolchain, not only the game executable, but also the development tools that we rely on in the process. Then there's the data pipeline. Internally, Cyberpunk 2077 had a full build pipeline set up for all the platforms we support, and we have added macOS as yet another parallel platform following the same process. The platform-specific outputs, such as archives and shader cache, had to be generated following this already existing pipeline. Finally, the architecture bridge. The game and engine had years of assumptions from other CPU architectures, so at the beginning of the process, we validated what works with unit testing and identified what changes were required to have it run well on Apple Silicon. After this step, we could move on to the shader pipeline. As soon as we had a basic metal path that could display frames, Metal Shader Converter helped us get broad shader coverage quickly so we could render meaningful scenes. In practice, we treated this process as a loop. Integrate Metal Shader Converter into our shader build, so Metal Shader output was generated as a part of normal builds, validate repeatable scenes, and look for differences in lighting response, materials, and post effects. Refine the smaller set of advanced shaders or edge cases where the converted result didn't quite match what we expected. Then repeat this process as a part of the build and test pipeline. In parallel to bringing shaders online with Metal Shader Converter, we were building out the native Metal rendering foundation. We started with unit tests, bringing the Metal backend up piece by piece and checking the base output carefully before adding more complexity. Once that base layer was solid, we moved on to stationary in-game scenes. That's where you can validate the parts unit tests don't cover very well: lighting stacks, post effects, and scene level behavior. After that, we moved into dynamic scenes where camera movement, streaming, and gameplay start to expose the real edge cases. When we implemented ray tracing and path tracing, we optimized the performance while validating that the visual output remained the same as other platforms to preserve the identity and look of the game. Once the native Metal foundation was stable, our next challenge was scaling performance across different Macs, and this is where Metal FX upscaling comes in as a solution. At a high level, Metal FX lets you render at a lower internal resolution and reconstruct a higher resolution output in less time. The practical benefit was quite straightforward. It gave us more performance headroom in the heavy scenes without lowering the quality across the board. We also used dynamic resolution scaling to help maintain stable performance under load across a variety of Mac hardware. As a temporal upscaler, it helped the image hold together in motion, especially during fast traversal and VFX heavy scenes. At that point, we had the full game on Mac, we had it running with a working build, it was rendering in a predictable way, and it was playable. From that point on, you really need to ask yourself, okay, now what actually makes it ready to ship? For us, it's few other components. There's the default settings, how it looks when you launch the game for the first time, then how we differentiate this version of the game with platform native features. And finally, polishing the game for a great overall experience. It was time to take what we have built and turn it into a first launch experience on Mac that really stood out. We wanted to provide great performance on the first launch for every Mac. That's where the For This Mac preset comes in. For This Mac is a device-based graphic preset system. It detects the hardware in your Mac and automatically configures the best settings for your device. Regardless of which supported Mac you have, you can launch the game and get a stable, enjoyable starting point right away. Our process started with picking settings that maintain image fidelity for each supported Mac device. We set our target FPS to either 30 or 60. Metal FX was used with dynamic resolution scaling, and we adjusted minimum and maximum resolution boundaries to hit the target FPS. Unique to the For This Mac preset, we also adjusted video settings. This was where we set the final output resolution, which dynamic resolution scaling operates within. We set VSync for proper frame pacing with our FPS target. We also enabled HDR based on the display's capabilities. We then further tuned every setting in our game one by one for each Mac to make sure they're not only performant, but also beautiful. When a player downloads the game and launches it for the first time, they can trust that it's optimized for their specific Mac. During our tuning process, what really helped us was using several consistent scenes that stress the CPU, GPU, and streaming systems in different ways. Then we collected performance data, refined our settings, and revalidated in a loop across the lineup until we found the ideal settings for each Mac. What's cool for us is, since the release of Cyberpunk 2077 on Mac, we've seen that other developers are starting to adapt For This Mac settings in their games as well. We think that it's pretty healthy for the ecosystem, and it makes us really happy to see it. Now, let's take a look at For This Mac in the game. Here is the For This Mac preset. For this MacBook Pro with M5 Max chip, I'm using the Ultra preset as a base. From here, I can see the rest of the settings. Starting with Metal FX upscaling using dynamic resolution scaling, targeting 60 frames per second and rendering anywhere from 50 to 80% of the target output resolution. Then I can go deeper into the settings, which were tweaked even more. We didn't require a lot of tweaks for M5 Max. It's quite a capable chip. We also adjust video settings as part of the For This Mac preset. Here, it's targeting a 60 FPS lock with VSync. Resolution upper bounds are set, and 2336 1460 is chosen for the internal display. Since the MacBook Pro's display is HDR capable, HDR defaults to on. HDR is automatically calibrated using Apple's EDR APIs. Players do not have to visit a calibration screen. It's a really great feature, which I'll talk about later. Now, I will load into one of the most taxing areas of the game. Yes, so this area is a part of Dogtown. If you played Phantom Liberty, you know, I'm not going to spoil the story here, but I'm going to load into the black market. This is the first moment when the player is actually entering this space. It's really dense in geometry, lights, reflections, and characters. It's one of the heaviest areas in the whole game. Again, this is demonstrating some of the quality bar that I spoke about earlier, where we really wanted to stress frame time stability in the hardest scenes in the game. Now, of course, in Cyberpunk, you have no loading screen. You can traverse the scenes in any way you want. Everything is loading in and out smoothly. And as I go around here, there's a variety of neon and light sources. It's really, really dense, and it's all running smoothly at 60 frames per second with out-of-the-box settings. Oh, these two gentlemen are actually our founders, Marcin Iwiński and Michał Kiciński. Our company started in a van, back when they were selling video games at the end of the 90s in Poland. So we scanned them and put them into the game.
Mamy vana pełnego przygód dla umysłu. Intensy dla każdego.
They're all speaking Polish in all localizations of the game. They're actually doing the voice acting as well. This is just one of the Easter eggs that we have hidden here. Alright, so we didn't stop at just settings optimization. We also adopted a number of platform-specific features around windowing and app switching, game controllers and input devices, display and audio, and cloud-safe technologies that let you play anywhere. Modern gaming intersects with multitasking. Players play in different scenarios and switch contexts, and macOS can let you know when these things happen. We wanted to create a smooth system experience for players. macOS broadcasts events as NS notifications that we can leverage. Responding to NS notifications events in the game helped us ensure the game feels native to the system, accounts for app switching, and reacts to display configuration changes. We also reduce our game's CPU and GPU activity while not in focus. Next, I'll walk you through some of these behaviors. First, we reduced activity while the game is in the background. When the game is not visible, we don't need to render and can save CPU and GPU resources for the player. For this, we listen to the window did change occlusion state notification to know when we need to check for changes, and then check for NS window occlusion state to determine if we should pause rendering or if we should start rendering again. Next, display settings. Players might change the settings of their attached display while multitasking. We wanted to make sure our game window is aware of these changes so it can correctly fill the screen. When we receive an application did change screen parameters notification, we get the new screen resolution and update our game window accordingly. Now, not only can the display settings change, the player may move the game to a completely new display too. After receiving a window did change screen notification, we collect details about the new display. This includes, for example, the display ID, resolution, mirror mode, and screen name. Based on this, we know if and how to update our game window. We are using our own cursor to match our game style. To create a seamless system experience, we listen to two notifications to manage the cursor when the game window loses focus. For example, when I open the game overlay, our game cursor disappears, and the system cursor appears to allow for a seamless system experience. When I close the game overlay, the system cursor disappears, and our game cursor appears, bringing us right back into the game. The window did resign key notification is the signal for us to show the system cursor and hide our game cursor. Conversely, the window did become key notification is the signal for us to hide the system cursor and show our game cursor. Aside from notifications, another thing to look for is the game mode. Game mode is a system feature in Apple that gives games higher priority access to the CPU and GPU and lowers the impact of background tasks, resulting in a smoother experience. It also improves responsiveness for wireless accessories by doubling the Bluetooth sampling rate, and that reduces latency for wireless game controllers as well as AirPods audio latency. And good news, game mode is automatically enabled for apps that are categorized as games, and our validation showed the benefits players get from it. Next, let's talk about input. On Apple platforms, the game controller framework made it easy for us to implement native support for a range of third-party controllers. It also supports advanced controller features like touchpad and adaptive triggers, which allowed us to easily bridge our existing implementations of these features in our game. We also support Apple's native input devices, the Magic Mouse and trackpad. For example, every Mac laptop has a trackpad, so make sure you design your control options to adapt to the current input. In our case, we automatically detect and enable toggle aiming and an alternative to the middle mouse button by using a modifier key and a mouse click. Now, displays deserve their own moment. Apple's high-end displays are some of the best we've seen Cyberpunk run on. Night City is built on contrast, neon highlights, dark alleys, bright signage, and they look incredible in HDR. We implemented HDR through Apple's extended dynamic range pipeline, which uniquely allows us to access information about the display so we can calibrate our HDR presentation automatically. This is such a great benefit for the players. They get the best HDR presentation and never have to manually adjust their HDR settings on a calibration screen with Apple displays. To dynamically calibrate our HDR output, we simply poll maximum extended dynamic range color component value to get the current maximum EDR value for our display, and then send that to our tone mapper. This value can change dynamically depending on the capabilities of the display hardware and other conditions. So using this to drive your tone mapper's maximum HDR output will always result at the best possible HDR rendering on Apple displays. We automatically enable HDR for displays with sufficient EDR headroom, such as Apple's XDR displays. For this, we check the maximum potential extended dynamic range color component value and see if the display's maximum potential EDR value is greater than 2.0. If so, we enable HDR by default for a seamless experience. Audio is yet another area where Apple platforms offer something special. Cyberpunk's 2077 soundscape is designed for spatial audio. We were able to take advantage of Apple's spatial audio APIs to enable head-tracked spatial audio for players with AirPods. This is a genuinely unique way to further immerse yourself within the game, and it's enabled by default with no additional setup. Our game has existing support for spatial audio with our audio middleware, and our audio middleware implements Apple's spatial audio APIs via AV Audio Engine. We enabled head tracking for earpods by setting the audio environment's nodes, a listener head tracking enabled property, to true. Finally, we wanted to reduce friction for our players when introducing our game to a new platform. On Mac, we support iCloud Drive integration, allowing you to transfer save files between your Apple devices. And because we have our own in-house cross-progression solution, players can continue their save across platforms. They can start anywhere, continue playing on Mac, and vice versa. So what's the outcome? A native Cyberpunk experience across Apple Silicon Macs with platform features integrated in a way that supports our quality bar. We have sold 35 million copies across all platforms and an additional 10 million copies of Phantom Liberty. It has been reviewed very favorably by our players on the App Store, which we are very thankful for. And Cyberpunk 2077 Ultimate Edition was recognized as Mac Game of the Year in Apple's 2025 App Store Awards. We are really, really thankful for this recognition. It was a lot of work, but we truly believe it was worth it. At the end of the day, what matters is not how much work you put into something, but what is the result for our players. All right, that's it from us right now, Chum. Thank you so much. It was a pleasure sharing this with you.
Thanks, Pavel. We hope you've enjoyed this special presentation. If you're feeling inspired, try out Game Porting Toolkit's evaluation environment to see how your next game runs on macOS. There's no code required, and setup is fast. Use MetalHUD to evaluate your game's performance within Game Porting Toolkit. Then, make your game stand out with a great first launch experience. Provide optimized settings for your players and enable platform-native features like EDR and head-track spatial audio with AirPods. Check out Speedrun Your Game Port with agentic coding to learn about new agentic skills in Game Porting Toolkit 4. Finally, you can discover powerful analysis tools in find and fix performance issues in your Metal games. All right, thanks for watching. We look forward to playing your games on Apple platforms.
This was cool. Got to know about the various aspects of Apple, specifically bringing Cyberpunk 2077 to Mac. I've been streaming for approximately 3 hours 50 minutes right now, and we'll take a break and come back later. Up until then, you guys can listen to some cool music.
ticket, meal ticket, come together lately.
By Big Lenbo.